Tech AV rolling the Ultros. I don't know, one of those. The Final Fantasy VI bad guy. I started playing. I was trying to test out Linux. I'm just rambling at this point, and you guys are just along for the ride. But I started playing. I've been trying to test out Steam compatibility on Linux. And like, it's amazing. Cyberpunk 2077 just works like it shouldn't. I'm getting 60 FPS, whatever. Full on Windows game. Doesn't make a bit of a difference. But I started playing the Tales of Berseria. So the Tales series, I never really had. The Tales series was never really on my radar. You know, Tales of Fantasia, Tales of Symphonia, Tales of Odyssey, and all these. There's like 16 games in the Tales series. And it's a JRPG that kind of feels like similar to Final Fantasy, the Final Fantasy series, because they've both been around for friggin' ever. So it was the first Tales game I've ever played, and I played it for about an hour the other day, and it was actually pretty good. So I think I'm going to keep playing on that one. And it was flawless on Linux.
If you ever get a chance, give Tales of Fantasia for the Super Famicom a try, because they really pushed that system as further than any other Super Nintendo RPG that I've ever seen. Like, it has a full-on recorded soundtrack opening and voiceovers and everything, which is not common on the Super Nintendo.
I was trying to figure out which Tales game to start with, and I was like, I should go to the Genesis, the Super Nintendo version, but I couldn't find a good Super Nintendo emulator on Linux. Everybody was like, use Higan, and then I downloaded Higan, and it was like super confusing and didn't make a whole lot of sense. And I was just like, all right, screw this. And I already had, I bought 3 of the Tales games that are on Steam for like, they were on sale one time, and I bought them, and I was just like, yeah, they're on sale. I'll just buy them. Maybe someday I'll play them. I think I got Tales of Symphonia, Tales of Berseria, and Tales of Zestiria. But those are all, like, Tales of Symphonia is even that's a PlayStation era game, and the Berseria, the one that I'm playing now, is like PlayStation 3, I think. So they're all still old, and so, but I was like, man, I don't know, part of me still wants to have started with the Super Nintendo version, but
I've never played any of the others. I've never even finished Tales of Fantasia, but it starts out really strong, and then it got hard, and I got lost interest. But I like are great for the era.
Yeah, it's amazing what like late JRPGs on the Super Nintendo were pulling off. Like, even Final Fantasy VI is like, you play Final Fantasy VI and you're like, the Super Nintendo was capable of this? Like, this is crazy. Like, just the breadth of Final Fantasy VI, like how expansive and massive it is a stunning that they could fit that on a cartridge. Like, you have a full-on JRPG that is like an involved game for 40 hours. And then they blow the world up and you essentially start another JRPG for another like 20 hours beyond that. It's like unbelievable what they pulled off. It's really cool.
I watched some documentary recently, some YouTube channel that does like all of their videos on Final Fantasy series, and what they claimed was basically they finished all of their goals for Final Fantasy VI ahead of schedule. And so they just started what you see as the middle of the game was supposed to be the end of the game. And so they just started throwing shit at it, and it ended up releasing late. But the cartridge itself was something like $60 or $80 in, 1994, 93 money. So that was an expensive game because it needed a larger ROM than most games at the time.
So that explains why there's effectively 2 full games in that game. I mean, I think that's what makes it one of the best Final Fantasies, though, is that like you build up this entire thing and then you lose. Like, you're the heroes and you lose midway through. And you're like, oh, Jesus Christ. And then you start over again. and then you win the second go around. But the fact that like the good guys, the heroes of the world, lose midway through is I like it was a plot twist that you never really saw in video games. And of course, this was like Super Nintendo was that shift from video games not really having a story to video games becoming these expansive novels with massive world building. So it was like a new medium, and it was one of the greatest stories you could have told on that medium.
It had some gut wrenchers in it, and also there's like 15 main player characters, but they actually take the time to develop a backstory for all but like 2 of them.
Yeah, it's it. I mean, it was really good. It's a really good game. Like that's the takeaway from here is like if you haven't played Final Fantasy VI, first of all, we just spoiled a lot of it, but also play Final Fantasy VI. It's really good. It's one of the best in the series.
It was the first I played, so it's always going to be the special one, my favorite. It was a lot of fun.
For me, 7 was the first one I played, which is why it's always special. And I think that's the same for a lot of people because that's why they're remaking it. But I would love to see them remake 6.
Yeah, I only played 10 and 10 too.
You only played what and what?
10 and 10 too. I haven't played any of the others.
10 is not one of my favorite ones. 8, I thought 8 was pretty good. 8 feels like the redheaded stepchild. Like nobody talks about Final Fantasy 8, but I really enjoyed it.
Yeah,
8 gets a lot of hate, but good God, that one kicks my butt every time. I haven't made it past the middle of it because apparently the monster difficulty scales as you level up, and I wasn't prepared for that.
I played it in high school with no life and no friends and no girlfriends, so I didn't notice the scale and difficulty.
Suzerain, have you been trying to cut in?
I was just going to say I joined in the middle of that when before the name of the game was mentioned. And I wanted to say I knew exactly what game you were talking about as soon as you mentioned the plot twist.
Oh yeah, how the good guys lose.
Yeah, I'm like, that's FF6.
Yeah. There's like, honestly, there's not that many games that have done something similar. Hilariously, I'm going to say Call of Duty actually did something similar. The first Call of Duty Modern Warfare. And it's like generic, boring military shooter. And you get halfway and you don't manage to disarm the nuclear bomb. And then it goes off and kills the character that you've been playing for the first, half to 2/3 of the game dies. And then you have to play a different character for the last third. So, like, when I think of, like, insane plot twists middle of the game, Modern Warfare crops up, Final Fantasy VI crops up. If I think of, like, games that had way more psychological punch than they deserve to, Spec Ops The Line is way up there. That game was like, that game turns you into a wreck while you play it because it plays upon all of the tropes of like a third-person generic military shooter, and it just like slips in this super subversive journey into insanity, journey into madness for the main character that you don't notice is happening until you realize that you have already gone insane. It's really like it's Spec Ops: The Line, I think, is probably the best of the generic military shooters. I play it every couple of years.
You ever played Phantasy Star?
I have not played it to completion. I've played a couple of. I played a little bit of the first Phantasy Star, which was Genesis, if I remember right.
Master System one, yeah. This is the one that my wife actually went and translated the remake, the Generations version, Sega CD. She actually bite edited all the Shift.js and translated the whole game. PlayStation,
Dang,
I'm sorry.
all right. That's dedication.
And she's not a professional translator, nor a professional programmer, but she got it would work. She got the ISOs patched to work.
That's impressive. Just because the amount of text in those games is on another level.
Yeah, people gave her crap because of the kerning was off in a few places, but she had to squeeze things together to make ASCII fit where Japanese, I forget the
Oh,
proper
yeah.
name.
Japanese is brutal about that. All right. That's on the wrong side. Our level shifter boards are on the other side.
Did anybody other than me ever play the original SNES Tales of Fantasia?
You came in late, Suzanne. We started this conversation by talking about the Tales series.
Oh, well, the thing that blew my mind with the original SNES, when I had a friend that was importing games, not exactly legal back then, but they had imported a copy of that, and it blew my mind to hear the Super Nintendo sing.
And I was really disappointed that they removed that from the Game Boy Advance port.
The Advance may not have been able to handle it.
Yeah, it used a specific hack for swapping out the basically it was doing rolling window DMA on hardware that didn't support it by playing games with the way the pages would advance. They had a SNES specific hack for it. Like if you try to dump out that part of the cartridge ROM data, the voice will just be garbage, but the rest of the SPC audio will be there intact.
They had the
There
Nintendo.
was a really impressive fan translation that redid all of the voiceovers too, like redubbed the whole game.
They had the Nintendo speaking, so I could see them doing. They have to make the SNES sing.
Roy or Reese, since it's been a full-on week since I did this, do you remember what order we went in for the 5 extra inputs and 2 extra outputs? So that way we can solder the right wires to the right places on the Arduino.
Yeah, about that. We went a bit fast, but I think we did the top 2 signals that were the terminal out, Litton in. And then we did the 5 outputs from top to bottom.
Okay, so yeah, that's topmost, that's second topmost. And then I think we just went in order, right?
Yeah.
Yeah, 1.
We pretty much went, or gonna fix it on the Arduino side.
Yeah, okay, so we I don't know what signals they are, but we start at the top of the board and then just go straight down. So whatever order that ends up is the order that we're in. So I'm gonna disconnect this and we're just gonna solder this to our little Arduino shield. I don't know where to put the Arduino while we do all this junk, but whatever. So
might it be a good idea to turn it on and just check to make sure that the voltages are good before we hook up to the Arduino?
Oh boy, yeah.
You want to smoke test it now? Ooh, I don't know if you guys could hear that, man. That thunder rattled the whole building.
Ooh.
Yeah, we can crank it on now, see what happens.
We don't hear it at all.
It's good.
Well, Discord, I should say.
Yeah.
Yeah.
That's probably the microphone doing good sound canceling there.
Yeah, it's the muff you have on the microphone. That's what.
Yeah. All right. So the inputs from the Arduino shouldn't be anything, so we don't really particularly need to worry about that. Let me see if I can get a clip onto ground here. That'll make my ground cable a little easier.
Let's just hope it's plus 18 volts and not the other kind.
Well, on the Arduino side, we don't want to see anything above 5 ever.
Yeah, sure. Yeah, definitely.
Or below 0.
Yeah. We probably don't
Eh,
want to see anything below 0 either, too.
I mean, it can
Yeah.
talk. It can have below 0.
Once.
All right. Let's
With
stick you in
low
DC.
enough currents, it can tolerate very below 0.
Let's get you on ground. All right, so we've got that on ground. These are, you guys can't quite see that. Let's get up and nice and close in case this thing does catch on fire. Ooh, look at that glare. There we go. Okay. This is, I don't know if you guys saw it. I ended up mounting this thing to a piece of fiberglass that just sits in the bottom here. And because it's all cut to the right size, nothing moves around.
Looks great.
While
Yeah.
looking at the
Turned out all right.
your other project, the TMS 9900, I was going, oh, a piece of wood would have worked too.
Yeah, I could have done a piece of wood. I had the fiberglass out there, though. All right, here we go. Power coming up. Power not coming up. I forgot to turn the circuit breaker on. Not the circuit breaker, the who's your what's it? There we go. Okay, now power is coming up.
The question is whether the front panel still seems to allow you to do Litton things, so we're not shorting anything to ground.
Yeah, see if we broke something here.
I mean,
Well,
except
nothing's
for
caught
like
on
power
fire.
rails.
The Litton does have lights on the front. And I don't see anything
There's
on
the drum
fire
coming
down
up.
here. Yeah, the drum is coming up. Ready light has come on. So if I do halt,
It does.
ready, run, it does run.
Okay, so that's good.
Yep. All right. So let's check some voltages here. Let's see here. These are the inputs, so these should just essentially be, all right, floating up to 5 volts.
Did we get a? Oh yeah, we got a 5 volts out of CR69.
Yeah. So these are outputs from the Litton to the Arduino. That one's at 0.6, 0.5, 0.3. Ooh, that one's like 0.006. That makes me feel like something's broken. That one's at 1.7. That's a weird level. Let's see, I think these are all...
It's at that point we realize all our transistors are backwards. Damn it.
Yeah, that's possible. So these are all the inputs seem to be sitting at 4.4 volts. Like, why would that be the case? That shouldn't be the case, right?
I think it pulls up the bus when it's not in use or something.
Okay.
The Litton does.
For anything that's coming from the Arduino, we have pull-ups to 5 volts to make sure the transistor is in a known state, even if everything's disconnected.
Okay, so that's what we're seeing then. We're seeing a pull-up to... So all the inputs are showing a pull-up to 5 volts. That's what we're seeing there. So the inputs from the Arduinos are all fine. The outputs from Litton to the Arduino all seem low. 0.8, 0.7, 0.6, 0.5.
Didn't we see a few weeks back on the scope that like when the Litton is not outputting, some of those pins just go absolutely crazy and just outputting any random signal. It's only when the device selects or whatever goes high or low that you actually get real signal. So maybe we're just seeing the thing that just seeing the everything flop around.
There's one of them that should be doing that. It's the select if it's data or status. Oddly enough, I've not even seen a write read status instruction inside the Litton code.
Was that
So
7
that's
volts?
hilarious.
Yeah, I was checking in different places. So
Oh, okay.
like 0.6, 0.5.
That could be the Litton just playing something low. Yeah.
Yeah, those don't bother me. This one at 1.7 is a little weird. And this one at 0.006 is also weird. That feels like a short to ground on it somewhere.
Might be.
So I think I might
I'm
pull
just
this
thinking
top board out.
it might be doing a lot of stuff right now. Reese, remember we're looking at the control signals.
Yeah,
Right
it's
now,
also-
the Litton is flashing. Right now, the Litton is trying to flash the ready light from the keyboard, so it's in that big loop.
Mm-hmm.
Oh, there we go.
So
I halted it, and this one came to life now. So it was running.
It was doing a lot of crazy things that were like selecting devices a lot of times. It's just not outputting data, but when it's outputting an address, it's essentially outputting data.
Yeah.
So
whatever.
everything should be moving. Or almost.
The moral of the story is that we didn't see anything that looked like it would catch the Arduino on fire, so I think we're okay.
Yeah, I think we're good.
Okay.
We just need to sort out which one of these signals is what when we hook it up to the Arduino.
Yeah.
Like,
The
which
only
is
thing
which is
is
output
we-
select.
So if we start from, I'm going to start with the inputs from the Arduino into the Litton, and we've got 2 of those. We're going to start with the control panel board. So we got 2 inputs from the Arduino into the Litton, and then we've got 5 outputs from the Litton into the Arduino. And if I go from left to right, that is going from the topmost connection on the main PCB up here and working our way down.
Okay.
So whatever that comes out to. What's up, Maiku Ando? Right. I don't know how to say that name. All right, so I'm going to do all the soldering up here, so that way I'm not killing my knees. Let's grab our Arduino here, this guy. And we're just going to make a little shield for it. And I'm going to rely on Reese and Roy to tell me what to solder where.
Roy, do you have that diagram of the board F PCB and what goes where again?
If you scroll up to my announcement, I attached that diagram.
Yeah.
No, I'm talking about the one on board F as well.
Oh, yeah. Yeah, I didn't attach that one.
I can paste in my notes of the board connection. Ooh, did I correct it? I didn't correct our last change for the interrupt pins. I just need a second. Oh yeah, essentially we're changing a B for a D.
Maybe just tack one pin there, David, so you don't melt into the plastic, and then take it off.
Yeah, I'm just doing a couple on each side because it's a double wide header, so there's a lot of tension on it. So I wanted to do a couple on each side, so that way I didn't bend or break the stuff here. Even that's still going to be a challenge to get out.
Paste in the text version of my notes.
There we go. Okay. Yeah, and then I'm just going to go through and tack all of
Stream is about a 10-second lag at the moment.
Yeah, that's typical Twitch Twitch lag. I think 10 seconds is about common for what we see on the Twitch stream, I feel like.
When we consider seconds per kilometer, that's decent.
I mean, it could be worse. We could be doing this at 9600 baud on an old BBS.
No, not that wire. The other wire.
The college I went to in 1991 to 94, for the first year they only had a 19.2 leased line, and so downloading Linux distributions kind of made everybody else unhappy.
All right. We need one wire from this to also go over to ground, but we'll deal with that last. Let me open up Discord here. So maybe I can see what's going to where. Oh, okay. Yeah, I got you. So K75, which is going to be the topmost pin on that one. That's going to be this one right here. So we'll start with that guy, K75. Let me get a... How long should I make these wires, I wonder? I don't know where I want to put the Arduino in there, because I don't particularly want it to be in there for permanently, because ultimately we're just going to make new connectors. So
Since you have the Arduino plugged into your laptop, just needs to be enough to get close to the laptop, I suppose.
yeah, that's really all I'm thinking about. So and that all comes in form of the USB cable, pretty much. So I'm trying to figure out where I can put the Arduino while it's plugged into the laptop such that it's not going to short out on anything else and it's not going to be in the way. I mean, I suppose it would be nice if I could like hang it in there, but I don't think that's going to work out too well. I mean, I guess I could put double-sided tape on the back of this and stick it to the side. Yeah, we could do that. We could just glue it to a side, stick it to a side. So we'll make it, oh, I don't know about that long. It feels good enough for me. So let me get 5 wires the same length. We're going to burn through a lot of my solid core wire here. Seven. We'll start with 7. This is still like a lot of wiring to solder up, man.
Parallel interface. They're always bigger.
It's crazy. Because we've got 7 control lines, then 8 inputs and 8 outputs. So
oh yeah, they didn't reuse the parallel lines.
I'm just gonna burn through all of my solid core wire. I'm gonna have to order more of these things.
How much wire did you burn through on the Data 620 tester? Because that looked like a lot.
That was a lot. Yeah, it was like a full reel of this stuff. I mean, this is like pretty cheap solid core wire, and I buy it like 4 spools at a time on Amazon. So it's like it's not a question of money; it's a question of inconvenience. 4, 5, 6. Because like I always run out when I'm in the middle of a project, and living out where I do, Amazon is 2 days at best. All All right, there's our 7 one of those. Cut an extra one here for reference for the I/O lines. What an unwieldy mess. Okay. All right, let's start with you, I suppose. I guess I'll just go ahead and get all 7 of the wires soldered up to my connector down there, and then we'll figure out what goes where on the Arduino.
Parallel the your scope on some of the signals so that you can watch them on there as well as the Arduino.
Yeah, we could do that. I mean, I only got 4 channels on the scope, so we'll have to pick and choose which ones are the best to view. But there's a lot of exposed solder joints on this thing, so hooking a scope on is going to be pretty easy.
And slightly dangerous, but easy.
Yeah, the scope will be fine. Everything else will blow up, but
Yeah, the transistors stop working when you let out the magic smoke.
yeah. Yeah, I'm curious how, because the Arduino code is, the Arduino code should essentially be ignoring every input until it sees a specific input go high. Right, till it sees one of the control signals do its thing. So I'm kind of curious how well our Arduino code is going to handle the chaos of the Litton ports.
Yeah, initially my dumbed down code I was trying to implement was just trying to find the easiest way to get all other transitions into the serial port, just to see what the heck are we looking at. But it's like, okay, we can push it to decoding the ASCII.
Yeah, so what's the Reese, walk me through the code that you wrote. Like I looked at it, but I had about 12 seconds of me time this week, so
Okay. So obviously in the setup, it sets up all the pins the way it wants. And then on the 5 status lines that come from the Litton, it's hooking up interrupts to those so that it can see the transitions as fast as possible. On 4 of them it is. I think one of them it doesn't bother. It's just the inhibit line. And then when that interrupt fires off, it like the output common, when that fires off, it'll read the 8 output bits from the Litton and put them somewhere. And then the main front end loop picks that up and prints it in the serial port. But I can quickly modify this to just dump the raw transitions if we have some problems with it.
I'm going to go out on a limb and say that we're going to have problems with it, but let's assume that we're not right off the bat and go for broke and hope that things work well. So the first time that we load up the Arduino code and I hit halt ready run, what would be an indication that things have gone right?
You would see some device select commons and some output commons. You should see some device IDs come out on the serial, and then maybe some ASCII characters. It might be the wrong ASCII characters if the bits are flipped around. But, if you can definitely make sure we hook up device select common and output common to the right thing, that will get us 98% of the way there, and then we can debug the others.
Okay. Well, no guarantees, but I'm pretty sure that if we go in order, we'll be okay.
Yeah,
I can give you rather than a hot ready run, I can give you a command to just select a device to start off with. You can put it on the front panel, and then we can just see if that device gets selected, and then trace the signals with the scope if it doesn't.
That's probably the smart move.
We don't see it in your emulator, Reese, but it should be flashing the ready, essentially selecting and non-selecting the device every 1 second or so.
Yeah, I haven't found that yet. Or haven't implemented that
I
yet.
mean, because you don't really have a spot for like a ready light, but if you look at it's always transmitting the like C0 and then 449 C0 49 C. It's or 4941 4941. That's just trying to blink the ready light. It's part of the Litton manual. It says, "Oh, it's waiting for the first input to input the program, or what do you want to do?" So
Yep, so we can look for that, see if it's selecting the device.
So we should be seeing a lot of device selections.
Yeah. So many that we might have to eventually turn them off once they're working.
All right.
I did make it so if it selects the same device twice, the Arduino sketch will just only print one notification, but we can change it to be constantly printing if it helps.
I'm pretty sure they're switching it off to on to off to on to make it blink. Actually, it's a bit crazy because this computer doesn't really have a time base. It has to essentially wait, I think, like 40 transitions. Like, it shifts in ones, and when it finds out it's a one, it starts shifting in zeros. And then when it's done a full cycle of that, it goes, okay, I should blink, change the state, and then do it again.
All right.
There's a whole loop for that.
We're starting with K75. K75 is an output from the Arduino, input into the Litton, correct?
Correct.
Yes.
And where should that one go?
So that's
41.
PG's.
41.
Yeah.
Great.
So on the outside of the double connector, the one pointing away from the small connector, I think it's 11 pins down from the top. 2, 3, 4, 7.
Yep, that's it. I got it lined up.
7.
That's going to be super duper annoying. What's a better way that I can do this?
If you put the cables in from the other side, you could use the lead to go onto the pin, I suppose.
Yeah, that works for the ones on the outside of the pin header, but not on the ones on the inside of the pin header.
True.
But I think I might do that anyways, and just route them out the corner. No, I can't do that because that's going to sit way too tight. So they would have to go backwards and around.
You almost have to like surface mount them.
Yeah, which I really don't want to do. That's going to suck. I don't have a good idea here. All right, well, let's go back to what I was doing. It's just going to be tedious, but it'll be the cleanest way. That's on 41. You said pin 41, right? Or connector 41? Yeah.
Yes.
Yeah. K75. Input busy.
Let's go ahead and lock you down.
I was just thinking of the difference in complexity between the logic in the Litton and the logic that's built into that Arduino Max.
Oh, yeah.
Oh boy.
There's probably more transistors on one I/O pin of the Arduino Mega than there are involved in the entire Litton.
No, I mean, the Litton has many transistors in every IC. Those flip-flops are not trivial.
All right, so the next one down.
Yeah, K76.
Yeah, K76.
Yeah, so that goes on the opposite side of the connector from the one you just soldered.
Great. All right. We're already going to hard mode. Okay. All right. So you're K76. All right. Opposite side, but same orientation.
Ah, you're looping them.
Yeah.
I thought about that.
It's slow.
That's good.
And a little tedious, but it's the
I'll provide more strength later.
yeah, it's the right way to do it.
Yeah.
Because I guarantee that I'm going to trip over this thing at some point in time.
At least you won't have to do the inboard ones.
Well, and since the wires are all the same color, that will make troubleshooting if you get multiple disconnected a little fun.
Super easy, barely an inconvenience.
Yeah, I worked around aviation, and yes, while all the wires may be white, they were all had numbers printed on them.
All right, so the next one down is now an output from the Litton.
Yeah.
So that one is on the small connector 4 from the end.
So that's going to be what, K80?
Yeah,
Kilo 80?
correct.
Yes.
Okay, gotcha. I'm super dumb. Oh, okay.
At least they're in order.
Yeah, well, I can't loop these because I didn't leave enough space to actually loop them. Well, I guess I can go on the inside and loop them that way. That'll be better. We'll do it that way. So that's the last, the last of the 4.
Yeah, the furthest from the double header.
Gotcha.
Yeah, I think they're in order, so you'll just have to move more towards the double header for the next 3.
I'm still going to ask you one by one just to be extra certain.
No problem with me. Oh, somebody was asking about the logic. Yeah, Litton uses TTL and has some DTL chips in it, but 5 volts.
Oh, fun. Yeah, Lopta, the Litton is a little weird. All right, the next one up is
K150.
we're K150. We're certain. Okay.
Hang on.
Yeah.
Have you got PD1 and PD2 reversed on your sheet there, Roy?
It would seem so.
Okay. Yeah, so right next to the one you just did, David.
Okay. Working my way towards the double pin header.
Reese, you did do them from the graphics, right?
Yes. I'll just go check that right now because you're making me paranoid.
We can always fix it in code, right?
Yeah.
Because I'm not unsoldering any of this stuff.
It's like the hardware engineers. So how do they fix a light bulb? They'll ask the software dude to fix it.
Yep.
Yeah.
All right, the
That's
next one.
my day job.
The next one in goes in the next location towards the still an interrupt pin.
Yes.
Okay. I'm getting slightly faster at doing this.
By the time you really get good at it, you'll be done.
That's the hope.
That's the classic.
I don't care as long as it means that we're done. That's the important part.
Yeah.
I'll fix my post. Just so we don't get confused.
The ICs in the Litton, are they standard 74 series logic chips, or do they predate that standard?
Pretty sure they predate it. There's some weird ones in there.
They predate the standard, but they all have pretty much good matchups, except for extendable ores. Those, I have not seen many of those.
That sounds like a very handy chip to have, though.
Yeah,
All right,
it's
the next one.
Yes.
Where's the next one go? This is the second to last one that we need to solder on the I/O.
So that should still be on the 4-pin header.
Okay, that's the last of the 4-pin?
Yeah.
Okay.
I did make a spreadsheet at one point mapping the 74 series to what the Littons were using, and they mostly match. So it's almost like they just had their own part numbers, but it could have been just predating the standard.
Yeah. The only ones you didn't really have were the DTL ones.
Yeah, because I have no idea what TTL is.
Yeah.
I'm a 5-volt man.
I think they use them as level shifters.
Be happy you're not dealing with the Bendix typewriter. That's got 160 volts hanging out on it.
Yeah.
And negative 20 volts.
That's too many volts.
Yeah, I know. 160 is like you mess something up and you know it real quick.
Yeah, but 120 volts with 2 resistors still becomes TTL level.
Yep. All right, what's this last cable here go to?
So that goes to pin 39, which is next to the first one you soldered on the double header.
Working, so next to the first one I soldered, closer towards the 4-pin. correct?
Yes.
Yeah.
Okay. Yeah, 41, 39. Let me just double check that I've got that lined up correctly. I'd hate to get everything off by one. Which wouldn't be
Yes,
catastrophic.
off by one errors.
We would just have to update the code.
It would still be a bit painful.
Oh yeah, it would suck.
These signals won't be too bad in the code. It's the input and output order of the input and output bits. If we have to reverse that, then I need to go write a table. Because at the moment I'm just reading it straight off the port, which is really simple.
Yeah, we just hope they match enough with the Litton. Because their odd choice for their 8-bit.
Yeah, the output side seems a bit more logical, but it's the input side where I'm not sure what they're doing.
If you look at the diagrams, they showed it in the diagrams that way, and it's like, why? Well, it's essentially always just a carry bit, except for when it's outputting a full data word or inputting a full data byte. Because it's essentially 7 bits. It's never really 8.
Okay. So next up, we're going to do the Arduino inputs into the Litton.
Each of the IBs.
Yeah. Now, I don't know what order I went in. I went in sequential order.
I think it was top
here.
to bottom.
Yeah, I think it was top to bottom.
Let me see if I can double check that right quick. It's going to be a bit of a tougher one to double check, but
I suspect IB8 might actually be the high bit of the byte, even though the manual says the low. I think it's just confused.
Weren't these were in some weird order, if I remember?
Yeah.
Yeah.
The manual goes on about how the low bit is the parity, but then in the actual code, it's obvious. In the obvious code, it's clear the high bit's the parity. So I think they confused themselves because of the serial 1-bit nature of the computer. I think the parity bit technically comes out last or something, or first.
I did the whole Verilog re-engineering of this thing. I'm still not sure my drum is spinning in the right direction. It's still pretty garbled.
What pin should be what here? Okay, pin 1 on the top connector, P9.
Yeah, that was IB7.
And then I think I go in order from there. Yeah.
I think so.
Yeah, okay. So I'll just leave it like it is. So pin 1's going to be on my far right. And then we just go progressively down that way. Like we're going straight down the board. So now I got to cut a bunch more wire.
We spent hours in this manual. I should be able to find this.
I need 8 of these. Two. Three. 6.
We have a request on chat asking what
Yep.
gauge of solid core wire are you using?
Oh, I have no clue. Does it say on here? No.
It looks like 26 or 28.
I want to say 22 because I see the number 22 on here, but that seems big.
No, 22
22
would,
is regular.
yeah,
Okay.
22 would be appropriate.
Okay, so 22 gauge. That's what I'm going to go with. That's 7.
I have huge spools of 24 gauge, which are slightly smaller than what breadboards want.
Yeah, so this plugs into breadboards pretty much perfectly. Which I think is why that's the gauge that I went with. But like Philip says, it might be 18.
I put the page documenting bit order.
Yeah, if I open up too many pages,
Yeah.
I'm just going to get confused.
Nah.
So you're just going to have to walk me through it one at a time here.
No, it's mostly for release.
Yeah, that's on the Friday Night Litton channel. If anybody wants to look at it on the Discord server.
Yeah, when I get back to my main desktop, I can post a link to this stuff somewhere. I'll just pull up my old orders. I need this one right here. All right, let's go. This is the tedious part of this. But it is a lot of wires. And we're going to have to do this again when we get up to the trying to make a serial board for this thing. But that'll be a little simpler because I'll actually make PCBs for it.
Yeah, because breadboarding DB25 or something else, not really great.
Yeah, I like making PCBs. I should have made a PCB for the top hat of this thing, but I just didn't have time this week. I'm also very much so going to have to mark orientation on this thing.
Don't know if anybody's following things with SpaceX, but they recently matched their Falcon 9 launch count from last year earlier this week. So they've still got another two months and a week left of launches to increase that count even further.
That's awesome, man.
They've got something like 90% of mass to orbit now. They did last year.
They're doing really cool stuff. I mean, say a lot of people have opinions about old Muskie, Hell, I got opinions about old Muskie, but SpaceX does not equal one man. SpaceX is doing some really cool stuff.
Yep.
Yeah, they're rebuilding all of the Starbase launch facilities, both Launch Tower 1 and Launch Tower 2, for the version 3 Starship launches. So it'll probably be 3 months, maybe 4, before they do another launch down in what used to be Boca Chica.
Yeah, I should really go watch
Oh, yeah,
a launch. Go watch a Starship launch someday. I mean, that's a rocket that's the size of the Saturn V, essentially, right?
Yeah, but they did taper it off.
I think it's actually taller and much heavier.
It's taller, heavier, and technically the Saturn V is slightly wider. Only at the base.
I mean,
Yeah, it's pretty neat.
The Saturn V for the era it was built in is just amazing technology. Because I mean, it's older than the Litton.
And it's older than most of the people in chat right now.
Even including me.
Right.
Yeah.
I mean, like, I obviously never got a chance to see a Saturn V launch because, I was negative years old. So, like, this is the closest thing that my generation will be able to get to watching that is effectively a Saturn V launch. And Boca Raton or wherever it is, I'm pretty sure it's down near San Antonio, right?
It's down near the border. Down near, I think it's near Corpus. It was Boca Chica.
Oh, Boca
Yeah.
Chica. Boca Raton is like a country or something, isn't it?
It's Florida.
Oh, okay.
Yeah, it's
Might as well be a different country.
The reason you're thinking about that is because that's where Word Perfect is from.
Okay. I mean, I should go see the birthplace of Word Perfect as well, but
Wasn't Boca Raton where the IBM division that designed the original IBM PC was?
That too. But
Yeah.
everybody saw that. Everybody that went through high school at some point had to deal with Word Perfect for DOS 5.1 or 5.0. And so
I didn't
everybody saw Boca Raton on the copyright screen.
Remember the keyboard overlays?
Oh yeah.
Yeah.
No,
Every once in a while, I find one floating around here still.
There for a long time, Microsoft Word had the key bindings built in for Word Perfect, but they eliminated that in like the mid 2000s. I took Word Perfect 5.1 in college, and high school for me it was AppleWorks on the Apple IIgs.
I was technically alive when Neil Armstrong and Buzz Aldrin landed on the moon. I was in my mother's belly when she was watching it on TV.
hey, that counts as life.
I was 7 months into gestation when the last Saturn V launched in 1973. So I was born in July '73, and the last launch was May 14th.
I've watched it on TV from my parents' couch.
Bob out here doxing himself with his real age.
Hey, I'm old and I'm feeling it.
Yeah, but you got to see a Saturn V launch, man. That's cool.
Yes, that was cool.
I got to see a shuttle launch in person. My grandparents lived in Florida, and as a very small kid, I got to watch a shuttle launch. And I remember even on ones that we didn't go launch, they were launching with such incredible frequency that I can remember the house shaking from the sonic booms of either them coming back to land or launching. I think they all landed in Texas and launched in Florida, or I don't know. Z would be the right person to ask about that.
The shuttle the shuttle landing locations were in Florida, at Edwards Air Force Base in California, and a backup landing site was in White Sands, New Mexico.
Okay.
They could also land them. They never did, but Bangor, Maine, of all places, could actually accept the shuttle if they needed to. So if they had an emergency, that was an emergency landing spot.
All right.
Yeah, they had a bunch of emergency landing sites around the planet.
Yeah.
One of the ones that you hear about that was never actually used is Morone, because sometimes on the ascent you would hear the call out 2-engine Morone or single-engine Morone. And that meant if they lost 1 or 2 engines, they could still make the Morone transatlantic abort opportunity.
All right. I have completely forgotten what order we're going in. Are we going left to right or right to left? I'll double check. Everybody's quiet, which means everybody else has also completely forgotten. We're going from top to bottom on the main PCB up here, which is going to be your pin 1, which is going to be right to left. So top to bottom is right to left. So I'll start on the right side. So that's going to be pin 1 of connector 9. Where am I going with that?
That's IB7.
So
We're going pin 1 of pin 1 of connector 9.
Yeah, P9 pin 1.
So those are going to be the.
You show that as on the old picture that I've got pulled up here. You show that as 26. No, C27. Wait, what? I don't understand your label here.
The C parts are the Canon connector. So it would be pin 28.
So
5 down and on the inside.
Yeah.
28, right?
Yeah.
Now, speaking of alternate shuttle sites, I had a buddy that was stationed at Vandenberg Air Force Base in the late 90s, and I did see where they had cut along the road to handle the wingspan of the shuttle, and also what was left of the Slick 6 launch facility that was designed for the shuttle to be launched for military payloads from Vandenberg, but was never used.
That's where they're going to use the fiberglass solid rocket boosters.
It may have been, yeah, because they'd have to abort them over land to drop them. I think it was their big concern.
I think it was also they couldn't do it with the weight as it was. They had to make it lighter somehow. But I wonder if that would have worked.
They never used it, so I think they have done. What's the rocket? The one that they launched that little Boeing space plane on. They launched those from Vandenberg. And of course, SpaceX launches from Vandenberg all the time.
Yeah, they used to launch from Vandenberg. I think they stopped producing that model. Now they only have the Vulcan rocket.
In the Northeast, we don't see a lot, but once in a while we'll see a launch from Wallops.
Oh yeah.
Oh yeah, a picture of Slick 6. Yeah, of the concept. I don't know that they ever fully built the vehicle assembly building that's in that concept drawing, though. I don't think they did.
Would have been hilarious if ULA got it.
All right, so the next one down is what?
Anyway. Next one down.
Yeah, so we did P9.1, so the next one's going to be P8 dot something.
Yeah.
F. So that's IB6, which is on in 27. So on the outside, 4 down from the top.
Okay. Pin. Gotcha. So why did you guys go back and forth with the pin numbers?
Because it's in order of the port in the Arduino.
So there's 8 pins around there that are all on port A, and so we can just read them with one instruction straight off the port.
Oh, okay. So there was actually like a legitimate reason why doing it that way.
Yeah. And it's the same with the output pins that we'll be doing later.
Not just to make my life more difficult with the soldering.
No. We may still have to pass it through a table. Yeah.
SpaceX's next Starlink launch will be from Vandenberg in about 10 hours, actually.
I feel like SpaceX has a launch in about 10 hours at any given time. Like when's the next SpaceX launch? Within about 10 hours, you know?
Well, yeah, looking at the list, it's like 10 hours away, which will be on the 25th. And then there's launch on the 26th, one on the 27th, one on the 28th, and one on the 30th. And they're all Starlink. They're all Starlink missions.
Yeah.
And there's now over 10,000 Starlink satellites in orbit.
That sounds about right.
Yep.
All right, so what's the next one down?
Next one down would be
I'm just going in order here.
5.
Yeah, 26. So back on the other side, up one.
Directly across from the one that I just soldered?
Yep.
Yeah.
Okay, I can do that. Oh, things are going to get a little tight here for a second.
Many more and the Starlinks will be able to touch each other? No.
Well, what's really impressive is when they get the next generation of Starlink out, when Starship starts flying, because they'll have cell to Earth capability for all carriers, basically.
Those satellites are going to be huge.
What blew my mind with Starlink was that the fact that they were able to pull off decent latency. Like I can online game with Starlink, which I think is insane.
That's insane. That's crazy.
That's because they're in low Earth orbit instead of geosynchronous, which is what HughesNet and the others used before. Which, geosynchronous is great for covering the whole, half of the whole planet at once, but latency sucks.
Yeah.
Yeah, you run into a speed of light problem there.
One of the other things they have on the SpaceX launch list is a total of their Falcon missions, and they have 562 completed missions, 522 completed landings successfully, and 487 total reflights of Falcon 9.
That's insane. I mean, the highest praise that you can give Starlink is that it's not exciting anymore. Like the Starlink launches are so routine that they don't even make TV anymore. Nobody cares. Which is like the greatest. That says how good it is. They're so good at it that it became commonplace.
I think the biggest thing that I think of with Starlink is a year ago when Hurricane Helene hit, and they gave Greg Biffle, the NASCAR driver, the retired NASCAR driver, over 300 Starlink units to fly in by helicopter and plane to provide emergency communications for free. And they unlocked emergency communications for free over the entire area impacted by it. That's just such a capability for emergency communications.
Yeah.
Yeah.
All right. What's the next one down?
Next one is 25. So it's diagonally from the one you soldered.
Okay, right next to the. So I'm just kind of going in a zigzag pattern is the impression that I'm getting.
Yeah.
I may be wrong here.
Mm.
All right,
You're not off by one, are you?
Probably. Let me double check some things here. So I've got 27 soldered. Which is correct, right? 27 should be soldered.
Yes.
Yes.
And then I've got 28 and 26 soldered.
Yes.
So why did we go in a weird zigzag? So we started at 28, then we went to 27, then to 26, but I feel like I soldered 27 first.
Yes, because we're moving down that number.
So I soldered 27, 28, then 20. No, that's not right.
We started with
I think
28.
you did. Yeah,
we started with
I think you
28.
did just. Yeah. We've just skipped PA7 or IB8 for the time being because that's the weird one.
Okay.
So 29 was skipped.
So I'm going to 25, which is 3 from the end.
Yes.
Okay. Well, if it doesn't work, then, at least our I/O signals I'm moderately confident are correct. Everything else we can figure out later. So there's a non-zero chance that you're going to have to modify the code to fix my poor soldering.
It's approaching It's close. It's approaching 100% chance. But I don't think it's because of your soldering. I think it's because the bits from the Litton are just in a stupid order.
That is also entirely possible. I won't take the blame for that, though.
Does Arduino support barrel shift?
No. But it gets pretty close. You can do it in 2 instructions if you have to.
Nightmare.
Okay.
All right, what's the next one?
So next will be pin 24. So opposite what you just soldered.
Also 3 from the end.
Yes.
Yep. All right.
By barrel shift, do you mean rotate?
Would also be named rotate sometimes. Could be.
If I remember correctly, depending on what model Arduino you have, there is an assembly language rotate instruction, but the C compiler doesn't know about it. You have to make it something that you can call or use it in line. And I don't remember how you do it.
I've used it because I've written crypto code that needed to use that stuff. So yeah, it's rotate through carry. So you have to then add the carry back in again.
Is there a pound ASM or something like that in the C compiler for Arduino?
Oh yeah. I think for what we're doing here, it'd just be easier just do a lookup table, straight into a big lookup table.
I mean, you copy one bit, and then you just do a shift.
Yeah.
All right, this is...
You certainly can't shift by 2 or 3 bits at a time efficiently, but 1 bit at a time is not a big deal.
All right, so realistically, how terrible is it if I have a short across pins?
You have to ask.
All right, I'm headed out, guys. Take care.
Take it easy, man. All right, what's the next one up?
So it'll be PA1, which is on pin 23. 2 from the end on the outside.
All right. And just for double checking, we have 3 wires left.
Yes.
Okay.
Yes.
Just making sure everybody's on the same page.
Yeah. We went 7 down to 2, 1, then we do 8. Because Litton.
But this is going decently quick. My loop method is annoying, but not as slow as I feared it would be.
It does prevent accidental pullout.
Yeah, it's great for strain relief.
Yeah, I'm definitely going to be using this idea in my next Arduino project. Thank you for teaching me something.
Oh, the loop method?
Yeah.
Oh, okay.
Never thought of that before.
I've done it before. I don't remember what project I did it on before, but I generally try to do it for these when I'm doing something on these proto boards because it's so easy to break a wire on the proto boards. So if you loop it around and you're using solid core, you got to really, really hurt it to break a wire. All right, what's my next one?
That would be IB1 on pin 22.
So directly across. Gotcha.
Yeah.
And then for the last one, we got to loop back. I gotcha. Because now we're because now we're getting into the 5-volt pins.
Yeah, we're getting to the output. Yeah, the Litton outputs.
Oh, with the what I think what you're saying is the one on the end of the connector is 5 volts.
Yeah, so I can't zigzag any further after this guy.
Yeah. Well, you could, but it wouldn't work.
Yeah.
It would be a stuck bit. It's like if you don't do the loop technique, you end up with a wire inside of a solder blob, and every time you try to correct your solder, your wire can pop out, which is great.
Yeah, the loop technique is like super robust, but also a giant pain in the butt.
I had designed a pad in KiCad to loop really big wires in that way.
All right, the last guy
goes all the way back at pin 29.
That's going to be on the outside.
Yep.
Yep.
Gotcha.
The last missing spot.
Yep, I got it. So we end up with 4 on each side of the connector.
Yep.
Okay.
Yeah.
And it ended up that way because they put bit 8 in a weird spot.
Yeah.
Yeah.
Like, bit 8 is your least significant bit. That's why it's just after bit 1.
But then elsewhere they say it's the parity bit, which is definitely not the least significant bit. So I'm confused.
They said parity is the least significant bit. Which is one way of putting it.
Yeah, I think Litton themselves were not great at writing documentation.
I'll get their big endians and little endians on bit order if they get weirded out and confused.
At the same time, because they're not manipulating bytes at any point except for loading stuff to the writing register, the buffer register, and they do that serially. It's like they can't transfer the wrong byte. They don't have much of a byte concept.
All right. Gotta tidy some of this up. All right, let's grab. This is an unwieldy mess, and I got 8 more wires to solder to this thing. All right. We're getting there.
And we're still going top down.
Yeah. Do the wires look blue on the stream, by the way? I see Nuka Nuki and Jbev talking about they're all blue. Is that what color they look like?
Dude, look
green to me.
I was gonna say they're very green.
They
green
they
here
look.
too.
Yeah,
Must be white balance.
yeah. They're kind of changing as you move between green and blue. It's kind of a aquamarine blue, so it is a bit green.
Oh, yeah, no, it's very green. It's like super just regular old straight green.
Yeah, they look blue on all my monitors.
This is the same wire that I used in the UE1. So like all the wiring for the UE1 that's like green and runs, connects the boards up to each other. Exact same stuff.
To me, it just looks dull, but that's because I'm green deficient colorblind, so my input is not useful.
I mean,
it's like when your arm was across the screen while you're working on it. It looked very green, and now that your arm isn't across the screen, the auto white balance has made it a bit more blue.
Okay. I just found it like I looked over and everybody was saying blue, and I was like, what? Nothing's blue over here except for the handles of my wire cutters.
And the Centurion.
Oh yeah. Oh, you guys can't see the Centurion. You can see the Phoenix a little bit, huh?
Yeah.
And the Sharpie.
Yeah.
Reminds me of the what color is this dress thing.
I know, right?
Yeah.
That's exactly what I was thinking of.
I mean, looking from my screen, even the Arduino looks blue. Well, bluish green, but it looks almost the same color. The problem is it the Arduinos that are bluish, or the greenish ones?
That was especially annoying to me because people would ask me what color I thought the dress was, and I would say, I'm colorblind, so I can't tell you what color it is. And they go, so everything you see is black and white? No, I'm not a dog.
You should have said like, yes, I literally have 1-bit vision, so it's either pure pitch black or pure blindingly white light. Just see how far you could run with that.
Even dogs have color, just one less dimension of color.
It's so funny because like I'm mostly deaf in one ear. I got like 70% hearing loss in my left ear, and at my old job, whenever I'd have to do like interpretation or something like that, I would always, they'd set up the chairs and they'd go, just sit here, and I'd go, hey, can we change the seating layout? And they'd go, oh, why? And I'd say, well, I need to sit on, that guy's left side because I'm deaf in my left ear, so I have to put my right ear towards him, otherwise I can't hear him. And immediately there was like a massive tone shift of like, oh my God, I'm so sorry. Like I had a disability, and I was like, it's like I can still hear fine out of the other ear. Like I'm not disabled. It's just I can't hear out of the left one.
The
Seemed like really weird.
Oh, I'm sorry about your hearing is what?
Yeah, what? What was that? I didn't hear you. Yeah, Zadster. I just, it's one of those things where like I just unconsciously now, because it's been this way for probably 6-7 years, I just unconsciously now walk on the correct side of people, and it's just one of those things that I don't even think about much anymore. It is nice when like, the missus is snoring. I can just roll over and put my good ear down, and then I can go right back to sleep. I don't want to.
So that's how I was able to sneak up on you on Saturday.
Well, you're a ninja. You're like a ninja with a huge beard, so.
I've done that all my life. I go and I sit and I join in on a conversation, and people How long have you been there? About
So I need
15, 20 minutes.
It like literally, that was like a jump scare because there was nobody behind me. And then I turn around and you're just like chilling, like you've been there the whole time.
I've been there a little while.
And I blame the people we were sitting with because they didn't even acknowledge you, and they could see
Yeah,
you.
it happens too. I've never understood it because I actually make a lot of noise when I walk around because I carry my keys and an old Altoids tin in the same pocket. Like, I'm not quiet, but still.
Well, I am kind of deaf, but also that place is super loud.
There were so many people.
There's a ton of people, but also Bingo doesn't really have great acoustics. Because they're a bingo parlor.
I got there earlier than I normally do. I was only like 15, 20 minutes late, and the place was already packed. I had to find a table at the very back because all of them were full.
Yeah. I got there about 12:10 or something like that. I think I got there roughly the same time you did. And yeah, it was crazy. I was actually like, I asked Kyle, I was like, what time did like this start? Because I got here pretty much right at noon and it was already full. It's like people were showing up at like 11:30.
Yeah, they were having to, you can't come in here yet.
Yeah.
I am a little disappointed to see it turn into more of a swap meet than what it used to be, but it's still really cool to see that many people showing up every time.
Yeah. And then there's, I would say that like, because what it used to be is still there. So like the same number of people that were exhibiting cool stuff, 5 years ago, they're still there exhibiting cool stuff. It's just that there's now more people doing swap meet stuff. So I would say the original show hasn't been diminished. It's just been fused with a big swap meet, it feels like.
Yeah, that's a fair point, I guess.
All right, we've got all of these are now what? So we did aioli last, so Arduino out, Litton in. And then next up, we're going to do Litton out, Arduino in, so Liao. And I got to figure out what order we went in. Okay. So on the far right, that's going to be here.
I think it's gonna be the exact same zigzag.
Well, hang on. So the far right is pin 2 on P9. The next one up is pin 3. So we actually, great. I go in the inverse direction.
Yeah, it's backwards.
Shit. All right. Well, whatever. Okay. So far right is, as long as we know, far right is pin 2. And then we just go upwards from there.
Okay. Also, we're going to be zigzagging downwards instead.
Yeah, we're zigzagging in the opposite direction.
Because Arduino also found it fun to invert their second port on the connector and have the bit order the other direction. They're fun.
And this is Litton out, Arduino in. So low I.
We essentially named the Arduino terminal, so it was pronounceable, but...
Oh yeah, you guys are doing Litton and Loti. The reason I'm going with A is because I already wrote in Sharpie on the level shifter board a giant A before you guys came up with calling it terminal. So I'm just matching to what I already wrote.
It'll work. You will be connecting it to a model 43, so it's fine.
Yeah, there you go.
I do have to say I like your latest plan for your layout that you showed.
Yeah, I was like super unhappy with where things were having to fit in the room. And then I was like, it was just like inspiration. It was just like, what if we made the Bendix at a catty corner? Like, what if it was at an angle? And then like everything else just fell into place. And I was like, well, now I have to get all of these extra things that are going to fill up the room. But the new layout does not have the 620 in it, the data 620 in it. So
Okay.
that's I'm gonna have to do something about that. I can't just abandon the project, so I think we're gonna have to get the data 620 into high gear.
And that was on the Patreon channel, right? Patreon chat.
Yeah, I haven't shared that anywhere else, so anybody that's listening is going to be super confused. So to anybody that's listening that is not a Patreon, I've been talking on the Patreon channel on Discord. There is a non-zero chance that I will be able to get my hands on a scanning electron microscope at some point. I'm talking with a really nice dude who's being super cool, and he works with scanning electron microscopes, and he's been like feeding me information. It's been a ton of fun just chatting with this dude, and so he's gonna try and maybe get the ball rolling to get one in my hands at some point. We don't know. I don't know particularly know when, but that's just something that we'll figure out. And so if a scanning electron microscope shows up, I've got to figure out where to put it. And obviously I'm going to want to put it right next to the BOMEM because, you know, they're kind of the same category, I should say, same genre. And I recently bought that NCR system, vacuum tube system. So I just kind of took a guess on how big that NCR system is. I could be way off, and that could really throw my plan out of whack. But so if I've got that new NCR vacuum tube system showing up, and I've got a full-on scanning electron microscope showing up, and I don't have a spare $30,000 to build a new room with yet, I mean, I could do it. It would be painful, but I could probably swing building the new room. But I'm kind of going, you know, instead of spending all of my money on this newer, bigger room, let's instead spend less money, but get cooler things and make this room work. See how well I can make this room work. And so I started, you know, wargaming the layout of systems in the room. I do this like every 3 months, it feels like. And so we came up with like a really cool idea to move the bookshelves around and, you know, get the UE1 and the proposed UE2 right next to the NCR system, which is right next to the G15. The LGP21 will rotate around onto the back wall over there. And then all of the other machines can push further down. The Litton will stay in the room, but the Data 620's got to go. Well, it's either the Data 620 goes or the Litton goes, and right now I'm having way more fun with the Litton than I am with the Data 620. So,
one of them does things.
Well, they both do things. The Litton does.
In a way.
The Litton does the correct things. It feels like.
We still have to go through the diagnostics of all the boards, and
but
there's the core memory.
But it did enough for us to. I mean, it's working enough for us to dump the. Oh wait, which one are you talking about? Are you talking about the 620?
Data 620.
Oh yeah, I was gonna say because the Litton works well enough for us to have dumped the drum. So like 90% of the processor is working, I would say.
I mean, it wasn't using much of the processor to do that.
Yeah, but I mean, if the processor was busted, it could be holding buses in the wrong places. It could be doing all sorts of junk, right? That would prevent us from dumping the drum.
All that we tested looks like it's doing the right thing. Yeah.
Yeah, but on the Data 620, like it's very clearly not doing anything correct. Like the
sure
registers don't look right. Nothing looks right.
Yeah, you're not able to toggle in stuff into the register consistently, and that's a bit weird.
Yeah.
And it's a bit sad that I did join this community for the Data 620, But I mean,
Well,
we
we're not
did
going to
the
give up
reverse
on it. Like I said,
engineering.
I'm not
We're-
going to abandon the project.
I mean, we did the reverse engineering. The problem is that backplane would be an inordinate mess
Yeah.
to reverse
And,
engineer.
Like, honestly, I think if we get on the Data 620, I think if we get, if we can figure out how to get my tester to test the register cards, and then we can test all of the flip-flops in the register cards, I'm thinking that we're going to find like multiple bad cards throughout the CPU. And then if we get those fixed, I'm expecting it to suddenly start behaving correctly.
I had trouble simulating those flip-flops.
Yeah,
I had to
quirky.
like bulk. I had to bulk up the capacitors in the simulation just to have a big enough edge to cross.
All right, did you guys take notes? Are we starting on the left side or the right side?
It would be the. Oh, we're starting with B8, right?
I believe so.
You guys didn't take
So
notes.
it would
I didn't
be
take
on
notes.
the.
I don't know why I'm blaming you.
It would be on the inside. So
is that the left side of my
30.
connector or the right side of my connector?
Oh yeah, no, that one.
I gotta know which side of my connector to start with.
your connector.
All right, let's try again. So if I start on the left side, that's gonna be pin. What pin should it be?
On the left side, it could be pin 2.
Well, the right side is going to be pin 2, I think.
Okay, so let's start with that.
All right, so we're going to start on the right side, which is pin 2. And then we'll just go up from there. Okay.
Okay.
So, starting on the right side is pin 2. That is this wire here. Where does this go on the Arduino?
Pin 30.
Yeah.
30.
So it's on the inside of the double connector next to all the other wires you soldered before. So
okay,
1, 2, 3, 4, 5, 6 down from the top.
Gotcha. Okay, excellent. There's a lot of wires on this thing already. It makes it very hard to handle.
Those are the last 7.
Last 8.
Did you hook up ground yet?
Not yet. Not yet.
Oh, yeah, that might be useful.
Yeah, we're definitely going to need the ground hooked up.
I had someone do an entire PCB. His microcontroller was working. Then he realized he never populated ground nor VCC. Still worked.
Yeah. That reminds me of the development of the ARM processor.
I was about to say that.
You know, their initial development system, they forgot to connect VCC, and the CPU was running off of the voltage from the I/O.
Yep.
I've done that. It works. Better than you
diodes.
imagine.
Oh yeah. Protection
Those
diodes save the day in a way.
All right, my next
Well,
one
eventually-
is
Across?
directly across from
Yeah,
it.
opposite. Yep.
Yeah.
Pin 31.
Gotcha. What a mess. All right. There we go. I'm gonna hit a point here where I can't get my snippers in there to Snip off the excess. It's getting very tight. And also super annoying. I have to solder that one from the bottom. All right. So next one is the zigzag.
Yep. Back on the inside. Pin 32.
Gotcha. Which is just right next to the one that I just soldered. The first one that I soldered, I should say.
Yes.
All right. I mean, I'd say we're making pretty rapid progress on this. This is going, I feel, smooth.
No, you just jinxed it.
I know, right? Well, it's because we haven't actually plugged anything in yet.
It's okay. I knocked on wood.
Thank you.
Okay, we're good. I'm fairly confident we're going to get something off the device IDs today. And then we'll see if we're going to have bit orders screwed up or not.
I'm fairly confident something will happen. Whether it's good or bad, or expected or unexpected, it's still something. Ooh, that's going to be annoying. I accidentally filled... You're right, I did just jinx it. I accidentally filled a hole that we're going to have to push a wire through a little later.
Where's the solder sucker?
I'm going with the braid. It's in an annoying spot.
I mean, at least the
Almost.
Litton outputs are in order.
Yeah, they don't do any wonky jumping around with bit 8. All right.
Yeah, the outputs will either just work or we just reverse the bit order and they just work. So there shouldn't be too big drama.
I did spend a lot of time to try to get them in the right order.
I'm sure you did.
Oh, we can always fix it. I mean, we can always fix it if we have to. But with 3 of us working on it, I'm moderately confident that we're going to be okay.
Like, the only thing that can really be a trouble right now if reverse transistors are not good enough.
Yeah, that could be an issue. We could have all of the transistors in backwards. I don't think we do. But you know.
I think your test earlier showed that there's probably low probability of that. I think they might be fine.
Yeah. All right, where's my next one go?
Be across?
Yeah, directly across.
All right. Yeah. Right there. On the outside, correct?
Yes.
Okay. I did a little rework in there, so I kind of lost track of where I was. So if the thing does work exactly perfectly, but if it
I got a whole list of Opus commands you can try. So,
Oh, okay, good. All right. Like, because if it works, like I'm like, great. I don't know what to do next, but if you do, then excellent. We got a plan then.
yeah. We should be able to get to the point of at least listing the program that's on the drum, the high-level program, if it works.
Would it work if it's not, if it was like pulled in through the tape and is not, it's not interpreted, it's a direct program? That's
You can actually. Yeah, you can actually write native programs and load them off tape and save them from tape, tape them to tape. There's actually a hidden command called J that allows you to jump into native code. So you can load high-level programs, low-level programs. It's all in there.
Did we find up what was up with the blackjack program?
I haven't had the time to look at that. It's in there, but I'm not sure.
Oh, so we're confident that there is a blackjack program in there.
We're confident there's something in there, but whether it's been partially overwritten or not, I'm not sure. But it definitely looks like there's native code in the first few tracks of the drum that Opus doesn't normally use. So it looks like there is native code there, but I haven't tried to disassemble it yet.
And I still find the whole configuration really weird, like all the upper tracks having like zero information in them. It's like
my guess
crazy.
is that all the software is pretty much written for a half-size drum, and so it just doesn't touch the upper half unless you got something specifically that wants the upper half. All right, so the next one is going to be a zigzag on the inside, correct?
Yeah.
Yes.
In 34, I think we're on. So if we do get all this working, probably the next big thing on the project is to see how we can scan all those tapes in, those paper tapes that you got.
Yeah, that's been on my list of things to figure out how to do for a while. So I've got that'll be a fun thing to try and figure out on stream. I've got a Rimex paper tape reader out there that I got from Kevin, the same guy that I got the Litton from. And it's a really nice paper tape reader, but he said, so his story with it was that he was trying to convert it to serial, and he got a pin incorrect on the conversion board and fried the ROM, and there's no more, that ROM code doesn't exist. So I'm not sure how best to overcome that. I mean, we could gut the whole thing, just use the paper tape reader part and then like stuff an Arduino in there.
Well,
right.
Yeah, that would make the most sense.
Yeah, probably easier that way.
Yeah, on that thing, it's a tool. Like, I don't care if my tools are period correct. I want my tools to work. So that thing, we're going to use it as a tool. So I'm totally all right with not being period correct and, using the correct period correct ROM and period correct, all this stuff on it. So I think what we'll do is we'll, dig into it, see what we're up against, and then make the decision whether we want to, gut it. And I'm just going directly across from that one I soldered, right?
Yes.
Okay.
The other thing I've been thinking of that other people can help with is whether we can write some new demo programs that you can load in at shows and stuff to show how the Litton works. Like, I've written a couple of programs, but there's all kinds of other things people could write. So we can write some new programs because we can load them in essentially from virtual paper tape with the Arduino or with a real paper tape reader on the real thing or whatever.
So this is actually kind of a fun conversation that I had with Lloyd and Bob and whatnot, right? And Ryan Burke, and like, how do you, like, what is demonstrate a system like this, right? Because the G15 falls in pretty much the exact same category. How do you demonstrate the G15? And in my experience, even the Centurion, which is much, much closer to a modern system, most people it's still so separated from what would be considered familiar that most people are afraid to do anything with it. So any kind of interactive demonstration that I had, nobody would do anything with. Even Snake, like I had Snake running at the event, and I thought people would be all about like multiplayer co-op Snake, and nobody played it. And it was kind of sad. So it's like, what's a good, like at a show, what is a good demonstration program? Or even, at a museum, right?
Don't ask me. I keep using Mandelbrot for everything.
That's what I ended up with, and I was like, Mandelbrot, man. Like Mandelbrot or Game of Life. That's like anything that's like a 0-player game is what you want.
Well, you had the Nova set up with BASIC, and there were people not even touching that with BASIC, right?
Yeah. All right. The next one is on the inside, correct?
Yeah.
Yes.
Okay. And then the last one's going to be on the outside. Ooh, I got a big old solder blob going on there.
You'd
I wonder if
always
it's
have
just
play global thermonuclear war.
Yeah. There we go.
Or tic-tac-toe.
Or tic-tac. So that's what Bob always defaults to for his stuff. He always defaults to tic-tac-toe because everybody knows tic-tac-toe. But even then, like that's gonna burn a little bit.
Yeah. But you're right. People are sort of afraid. They're afraid they're going to break it or something.
Yeah, that was it too. Like with the Centurion, people were like, "Oh, I don't want to hurt it." And I'm like, "Man, you like literally like I threw it in the back of a truck and drove 2 hours to get here. Like you're not going to hurt it." But I get it. You don't want to break somebody else's system, particularly when it's at a show. But like that's and also there's a lot of people at shows who don't want you touching their system, which doesn't make any sense to me because that's not the type of person I am. But I get it, I guess. So it comes down to like what is like whatever you demonstrate has to be like multifaceted, right? You have to have something that's like 0-player, Game of Life, Mandelbrot, and then you need to be able to rapidly switch context to something that is interactive, I think. Games or something that if you have somebody who shows up that's keen and is like, I want to get hands-on with this machine, then you can be like, all right, Control C, let's go. Load this up. You're now in control. Have fun, bro. Yeah.
It's like something to represent what the Litton does. It's like hardcore accounting.
Yeah, well,
great.
that's like,
I do that for jobs, so that's not great.
Yeah, that's why like the blackjack program is kind of promising, right? Because that's like a period correct piece of software that somebody could get hands on with. All right, so this last one goes on the outside, and it slots right in between the other pin that we soldered and one of the interrupt pins, correct?
Correct.
Okay. Yeah, one of the input pins.
Yeah, one of the input pins and or the I don't know. What are we doing input or output right now? I don't know what we're doing right now.
Right. Litton out, Arduino in.
Sure. I'll take your word for it. I'm completely lost.
It's the inhibit pin. We're not putting it to an interrupt because it shouldn't be changing states.
Yeah. So inhibit basically says that the system is still warming up, so the peripherals should not do anything. They should just reset themselves. But then after it's warmed up, it's useless.
Inhibit pin is essentially cabled to your ready light.
Oh, so it's literally just it's literally used once and then never again.
So that's what changed when you halted it.
Oh, maybe.
That's quite possible. Yeah.
I mean, the ready light stays on when you're running or halted. It doesn't really change.
All right.
It's just, is it hot? And is everything okay? It's like if it lost AC, we would lose the inhibit pin would immediately shut off. I mean, turn on. Good question.
You know, the software discussion about demonstrating systems got me to thinking about arcade games and attract mode. So maybe if Snake had an attract mode where it plays itself until somebody hits a key to play it.
Yeah, I mean that's possible too, right? Like, because arcade games always had the game playing until you walked up, right, and hit a button, and then it would go back to the main menu.
Dropped in a quarter, yeah.
Well, yeah, I'm thinking of like at modern arcades where everything's free to play.
Right. I knew what you meant. I just, yeah.
All right, so this is the ground wire. And we gotta solder ground onto the.
The question is, do you have the Arduino IDE installed?
Oh no! Well, it depends on what machine. Yeah, no. So we'll just say no.
Okay.
I have it installed, but it's installed on the machine that's streaming. So if I try to run it on that machine, it's guaranteed to crash the stream.
Yeah. I just had a thought about the tape reader. If it has enough I/O, if you put a Pico 2W in the tape reader, then you'd have a Wi-Fi connected tape reader.
That would be kind of funny. Supposedly that, like, it's a really nice Rimex. And so supposedly it can do, like, it's like crazy fast. Now, if we ditch all of the if we ditch all of the internal electronics, it's on to us to figure out if we have a good read of the tape or not, right? So we got to do like checksums or whatever, or I don't know, read it twice or 3 times, right?
There's the parity bit, but that's just slightly good enough parity.
But that's only that only works if it's a Litton tape, right? And you know that there is a parity bit or where the parity bit is. That doesn't work for unknown tapes. And so we would like the thing to be usable for, unknown stuff as well.
So you could have a general purpose 5-bit or 8-bit tape reader.
Exactly. So that way, if I come across, some other Bendix tapes or whatnot, like, we can read them.
Yeah, you'd hope there's odd and even parity, and it could be anywhere.
Yeah. So the way Lloyd dealt with it was he read each tape 3 times. So Lloyd made a home-built paper tape reader, and he read a lot of the tapes from System Source and I think Living Computer Museum as well. He took his up to Living Computer Museum back when they were still alive. But yeah, he would just read tapes 3 times.
Now, earlier you were talking about extreme accounting. There was one of the people with an AS400 that was talking about, as a demonstration, replicating Bernie Madoff's AS400 setup, where he had a shell, 2 shell companies concealing another shell company, and how somebody had found it and reported it, and that's what got him busted. And in the end, it turned out there wasn't quite enough publicly available information to do something that would withstand scrutiny. And so they also didn't understand enough of the accounting principles to actually do it. But something along those lines, or something like the one with where somebody was stealing time on a VAX and it threw their accounts off by a penny. What was that? The Blue Falcon or whatever it was. something like that might qualify and make an interesting demonstration.
You guys are making me crack open my last roll of this green wire here.
Yeah, no, you just do a balanced ledger and you just do an off by 1 error. So
You do the
Look at
Superman thing. You do the rounding things. You round all the pennies down and send the excess to yourself or whatever it was.
Like Office Space.
Yeah, Office Space. Except they messed it up so bad that like they clearly were going to get caught.
Yeah. Yeah. Milton and his red stapler. Best part of that movie.
Yeah, that's Stephen Root, man. Stephen Root is one of the greatest actors of our generation. That dude is unbelievably good.
And you've got to think that was a movie, written by Mike Judge about his experience with such things, and he's even in the movie.
I didn't realize that.
He's the manager at Tchotchkes that's telling Jennifer Aniston that she needs to wear more flair. If you listen, he sounds just like the school teacher in Beavis and Butthead.
That's hilarious. I didn't realize that was him at all.
Yeah. I don't think he made a cameo in Idiocracy.
The documentary?
Yeah, the documentary, you mean?
Yeah, the documentary Idiocracy.
It's what plants crave.
Did you hear about the story about Idiocracy and why they didn't market it?
No, because I didn't hear about it until like years after.
What happened was, if you notice, there's a lot of product placement in that, but they did very rude things to those products.
Okay.
Like Starbucks and Fuddruckers and even Costco a little bit. I'm not saying what the movie
no.
They're not on this stream. That would violate the no.
You can say the Costco bit, which was "Welcome to Costco. I love you."
I love you. Yeah, the Costco one's okay. But anyway, to finance the production of the movie, because the studio decided they didn't really like it because the studio was going through some changes, so they paid half of the budget to make the film by these product placements, and then he did that with them. And so to keep from being sued, the studio decided not to market it at all and release it in like the minimum number of theaters they could contractually. And for 1 week only.
Oh, geez.
That's all it ever got in the theatrical run.
They were rough on it.
But it made so much in home video sales, it more than paid the budget.
Oh, yeah. It was a wildly popular movie once it was out of theaters.
Yeah, it's one of those cult classic movies, Yeah.
If I remember right, there was one of the brands did find out what the content of the movie was and demanded to be immediately removed. And so they had to do a bunch of late edits to replace that one brand.
It may have been a fast food restaurant that got replaced.
Yeah, I want to say it was McDonald's, and that's why we got Hardee's.
Yeah. If you've seen interviews with Terry Crews, he talks about how, what is the guy's name? Mountain Dew Camacho, the president?
Yeah.
How that's one of his favorite roles. And that was one of his earliest acting roles.
Yeah, it was something Harrison Elizondo Mountain Dew Camacho.
Yeah.
I
don't remember the whole thing, but he had like 8 different names.
Brondo, it's what plants crave.
Yeah, that's right. But it's got electrolytes.
Yeah, it's such a beautifully done.
Do you even know what electrolytes are? Like, what is an electrolyte? It's what plants crave.
You mean water? What we use in the toilet?
I had a moment like that at work. My boss was had a cold, and his nose was running very badly. And I noticed he would go into the bathroom, and then he would come out, and he was in pain. And he went back to his office, and like the third or fourth trip, he made some kind of remark about these paper towels are killing me. And I said, Gabe, are you wiping your nose with paper towels? He says, yes. I said, use toilet paper. And he says, like on your ass? And I said, yes, Gabe, toilet paper is made for use on skin. Paper towels are made for use on surfaces. And he just goes, oh.
I made that one way too short, but whatever.
The only thing is, if it's scented toilet paper, yeah, not enjoy it. Having that smell there for a little while. It's just a little odd.
You don't pay for
You didn't hear what you
scented.
said. Your volume was too low.
Well, that's super unwieldy and not great. And my ground wire is too short.
Fun trivia. They tried making toilet paper with lotion in it, like Puffs Plus tissues. Nobody liked it. Didn't work. Never made it
Yeah,
to market.
It's the does it feel clean issue, you know? And it would not.
Yeah,
you guys are all
that. Yeah, I remember that.
You guys are all barbarians if you don't use a bidet. Just get a Toto toilet and be done with it.
No, I remember back in it was either the late 80s or the early 90s.
All right.
My stepdad.
Nope. What's that, Dave?
Did I step on you?
Oh no, I'm muttering to myself. Sorry.
Oh, okay. No, I thought I interrupted someone. Anyway, I'll make it short. My stepdad paid a truck driver friend of his to smuggle an illegal toilet down from Canada because we had a
so short
water usage limit here, and so you could not buy a toilet that did not have a limited water tank to limit the amount of money. Or not money, to limit the amount of water that would be consumed in one flush. And so he had this toilet smuggled in for him. And it was they made all these all these funny shenanigans trying to get it in the house without the neighbors figuring out what it was. We still have the toilet.
There's actually a market for older toilets because of that. People would buy, ones that have been removed for renovation. It's also why you'll notice that almost all shower heads have an easily defeatable flow restrictor in them.
I always thought that was supposed to be optional based on what jurisdiction you were in. Like if your jurisdiction required it, you were supposed to leave it there. But if your jurisdiction didn't, you would just take it out.
There's a federal law that says that they have to have it there to sell them, but it doesn't say you can't use them if you remove the flow restrictor.
Okay. So, I thought it was like a state level thing.
But yeah, in California, it's technically illegal to remove the flow restrictor from a shower head.
It's like the tag on a mattress.
Well, yeah, that's only to be removed by the consumer. So, yeah.
All right. I've been ignoring Twitch chat because I've been soldering, but I got Twitch chat pulled up now, so I apologize, Twitch chat, but I am now paying somewhat of attention.
That's okay. Apparently people were learning anyway. What they were learning, I have no idea, but
I think the last major question you might need to answer is if there were any substances from the older machines that you need to worry about from like a hazmat perspective.
I don't know about Usagi's specific machines, but the thing I can name off the top of my head is machines that had mercury delay line memory. I bet that would make the local hazmat authority have kittens. You have how many little vials of mercury in your machine?
Yeah.
Can I not just do a
Little?
sudo apt get Arduino? I got to get the app image.
I'm not sure. I mean, it used to be. I think.
Sometimes it works. Just give it a try, but otherwise you can install from the net pretty quickly.
Yeah, well, I'm downloading it now, so. But it, like even on here, it says I have to allow executing file as a program, and then I run it directly as the app image, so it doesn't actually install. Just a weird choice.
There may be some low-level I/O to USB that's required, or is that's all through a serial interface though? So maybe it shouldn't.
Whatever, I'm just gonna put it on.
Sometimes you have to give the device permissions.
Yeah, you might have to have your user account in. You might have to add your user account to the correct group for accessing serial ports.
Yeah, the other thing you can do is if you're not sure if something is apt gettable or not, do apt search whatever, and it will search the package database and tell it to you.
All right, there we go. I got a sketch open, so that's mostly of a success, I believe.
Oh, they have a browser version now.
All right, so it says it's downloading packages and installing stuff here, configuring, installing platform. So,
that's a good start.
Yeah, it's a good start. It's doing stuff. Installing Firmata. All right, so while that goes, where's your code at?
I put a copy in the chat just after the diagram that you were looking at earlier. Just go up.
Well, you got about 10-second delay here, so there it is. I got it.
Okay.
All right, let's again. I'm just gonna cut you, put you on the desktop. All the things I've learned about how to use Linux in the past 5 days of like daily driving it on my desktop, I now need to implement on my laptop. Let's go file. Let's open your sketch.
Oh, I didn't know you'd switched. What did they sucker you into running?
Oh, I'm running Mint. I was going to try and run Kubuntu, but Kubuntu would absolutely not play nice with my my video card. Why did that open in a second window? What are you doing?
Sometimes does that. Because you already had a sketch, so you're opening a new one.
I wanted you to open in the same window. All right. Does it even see my board here? Oh, it does.
It should be.
All right. Let's just upload.
Okay. Let's just go for it. See what happens.
Let's see here. AVR dude can't open device. Permission denied.
Yeah, that's what I expected.
Yeah, so now
don't you have to put a udev rule in?
Yeah, I think so. I don't know how to do that.
I mean, you can just, if it's like Debian, you can add yourself to a group. Which one is it again?
Oh, that's
I think.
Changed now. That's all changed now. Now in fact, there's a whole big fight going on about it earlier this morning.
Really?
Yeah, you can't add yourself to a group. There's a systemd thing you have to do.
Go. Sudo usermod -a-g dial out user. I can do that. Let's try that. Thank you, Charles.
Well, then, yeah, now that I think about it, though, you're probably not on current on your laptop. So just doing the group thing will probably work on the laptop.
Usermod -a-g.
Oh, wait, there should be a post install script.
It wasn't an apt package.
Is when you write $user, does that mean I need to do the $sign and then my username, or is that just the way you write user?
$user is a variable for the current username. So
Yeah.
you can either type that or Usagi or whatever your username is.
I would just type your username, no $.
Okay.
$sign before something means it's a shell variable.
Okay. Let's see if that changed it. All right. Let's try uploading again. Upload. Can't open device. Dev TTY ACM 0. So that did not fix it.
Does the no? I guess the device file probably does. We'll see if the device file exists. It might be like UDEV being stupid and like renumbering it.
If you have a different ACM, it might be ACM 1, ACM 2.
Yeah, ls dev ACM star and see what like.
Someone on the chat just said you might have to.
Or TTY ACM, yeah.
Oh, I'll need to log off and log back on again. That's right.
Oh yeah.
All right, that's fine.
All right. No, it'd be TTY ACM actually. ACM in all caps. Yeah, you would have to log in and back, and you'd have to log in and out to make the group take effect.
Yeah, I forgot about that. If you guys can figure out my password from the low resolution shot of me typing on the keyboard, I will be impressed. But also, please don't try to figure out my password.
My good friend ChatGPT will probably be able to figure it out.
Oh, Jesus Christ.
I was about to say there are bots that scrape VODs looking for passwords and shit.
I was just reading an analysis of why AIs have a tendency, why large language models specifically have a tendency to hallucinate. It's because it's better for them to make stuff up than to return no value in the way that they're written.
Oh yeah, it's the same way you deal with management.
Exactly.
This is actually a good analogy.
Yeah, I just wish the vendors would just realize it's okay to say, I don't know.
No, it's not. From experience, if you are on a service call and you are being sent out to look at the customer's $10,000 enterprise printer, and your second level of support is on the phone waiting, and the customer walks up and says, have you seen this problem before? They do not want to hear the true answer. I've never seen this equipment before. They want to hear, yeah, I've seen this before. It's irritating. There's supposed to be a fix soon, but they've been saying that for months.
All right, let's try to upload this again, see what happens. Done uploading.
Yay!
Heck yeah. All right, so now I need to go. I mean, it should just automatically be running now. So I need to go to the serial monitor, correct?
Yeah, let's start. You might want to use Minicom or something to talk to it instead, but let's just try the serial monitor first.
Okay. Okay. I'll get a picture of this right quick.
Say there.
All right. Well, knock on wood. Hopefully the Arduino doesn't go up in smoke, but Litton is coming online now. Right? We didn't miss anything that we know of, right?
Looks okay.
All right. The Arduino didn't catch fire. That's a good start.
Laptop didn't catch fire, which is good too.
Streamer we got still online.
Some weird outputs out of the serial monitor. The serial monitor is tiny. Oh my gosh, I wish I could zoom in on it.
I think there's a setting for font size. Oh, and CU is specifically supposed to be one of the things that's deprecated going forward.
All right, so yeah, we definitely should go through like Minicom so I can make it big. How do I know what? So dev TTY ACM 0 is what it looks like.
Yeah, if you have a look under the tools and the port number under the tools directory, that should tell you which port it's on.
I don't know what that means.
Oh, you already quit out. Sorry.
Oh, you mean the tools of that thing? Okay, I got you. Well, it said it was. So if I
it
do
was
like
just
ls,
you could have seen in it.
TTY ACM0 is listed in here, right? So I should be able to just go like sudo minicom because I haven't added myself to that. How do I tell minicom to like start with the setup? -S. Yeah, there we go. Serial port setup. We want to go A, so TTY ACM0. And I'm pretty sure that it's at 9600 8N1.
No. 115,200.
Be sure?
That's what I put in the sketch.
Oh, all right. What was it? 115,200?
Yeah, for the board rate.
8N1?
Yep.
Okay. That should be good. How do I go backwards from this setup menu? Q? Escape? Yeah, escape.
Hit enter.
All right.
I forget myself.
Go save setup as lit. Let's exit from you, which should put us here. So I'm getting not ready. I don't know what that means.
Oh, that means the inhibit. So is the ready light on the Litton or not?
Yeah, ready light's on, but we're halted.
Just flip
It might be negative.
That also might have just been like sitting in the buffer, right?
Okay. Do halt ready run.
Okay. Halt, ready, run. Yeah, nothing.
Bugger.
What's like an input that I could hit?
The
like it's still
N
running,
command
so.
should be.
N?
Yeah. The N command is fairly innocuous. And N for number.
November.
Yeah, I'm not getting anything back.
Okay,
Nothing
we're
is
gonna have to go a bit
echoing.
deeper on this.
Nothing is sending.
If the Arduino application is still running, check and see what's on its serial monitor.
It is not still running.
Be.
Okay.
I can control A Z. How do I exit out of minicom? Now that I have the minicom set up, I can do it. Oh, hey, hitting control caused the Litton to do something.
What?
That's weird because control by itself shouldn't send anything to the other side.
Yeah. Control X. How do I get out of here? Control AX. Control AX. Yes. There we go.
Yeah, Control AX could exit and free the port. Control AQ exits without resetting.
Yeah, so if I go back to the Arduino IDE here, the serial monitor is up here. You said the baud rate was 115,200. Going real fast on the baud rate. So if I do a halt, ready, run, I got nothing on the serial monitor here either.
You might
turning the Litton off and then back on again.
Okay. That said, device select off, device select 0x2C, device select 0xFF. Oh, no, device select 0xFF, device select 0x2C, device select 0xFF. Three of those rapid fire.
I think we're going to... Can you take a picture of that and dump it in the chat? I just want to take a quick look.
Yeah. I'm going to switch back to minicom because it's bigger font.
because I know what device IDs it should be doing, and this will tell us if we got which way around we got the bits.
What I was worried about is that the Arduino IDE might be stopping the Arduino processor when you tell it to exit. It might not be leaving it and run.
I don't think so.
You can just hit reset on the Arduino for that.
All right, let's get back into Minicom. Oh. How do I load a setup?
Just type the name after, like, instead of -s, whatever you saved the setup as, type that name instead of where, type that name where you have the -s.
Okay.
Take the dash out too.
Yep, I gotcha.
Right. And that should load whatever it is.
Now that you're in the dial-up group, you probably don't need to use SUDO for Minicom.
Oh, yeah, that might be true. Sudo? You want to start a holy war in the comments?
Sudo is perfectly reasonable name.
The real holy war was the fact that I used sudo for an assembler. I got a million comments on that, and I swear up and down that it would not run without sudo. So, I don't know, maybe I had something set up wrong. But people were very
permissions when you installed it.
People were very, very upset that I used sudo for an assembler.
If the assembler was installed as root.
I'm trying to control the brightness a little bit here so it doesn't blow out. There we go.
Yeah,
all right, so what am I doing next?
So I'm seeing not ready on the screen. Just try the turn Litton off and on again, and just see if the device selects comes up here.
Okay.
Isn't the Litton already off?
It was off. There we go. So we got device select 0xFF followed by device select 0x6D.
So that's different than last time. And the Litton is running. It's just happily chugging.
It's spinning up right now. I mean, the ready light's on, but it's still halted.
Halt, ready, run.
Yep. Alt, ready, run. We got a tab. Well, maybe. I don't know if that tab was there. We got another device select. We got a device select 0xFF.
Yeah, I think bits are a little bit screwed up here. But so what? When you go to Opus, the first thing it does is prints a CRLF and then waits for input. So just hit a key, just any letter. You can't harm the Litton.
Oh yeah, even erasing the memory requires really awkward key presses.
Yeah, it looks like it's on.
Didn't do anything.
We're going to have to do some lower level debugging.
Does it have to
What's
be
your time like there?
cap lock, maybe?
I did actually take care of that, so that won't matter.
Oh, you did?
But you
I
can,
mean, I can see that they're sending.
One thing we can try is just change to, because currently it's set to negative logic. We'll just change the sketch to positive logic and see if that makes any difference, but probably not. The fact that it says not ready, but never says ready is kind of weird.
Okay. The other thing is throw in a command that just dumps the line states.
Yeah.
And that would make it easy to see what it's doing.
So I can change the negative logic to positive logic real quick, I think.
Yeah.
Did you
at the top of the sketch
interpret the inhibit bus correctly?
So I can just swap the L high and L low, right?
Yeah, and also the rising to falling.
Oh, L rising right now is set to falling, so I need to change it to rising.
Yeah.
And I can upload that.
Yeah, I think basically what's going on is none of the interrupt-based things are working at the moment. So yeah, I'm going to have to write some sketch that dumps the raw signals. I think it's basically working, but we're missing something.
Yeah, I got not ready and then nothing else.
Are you doing something with the inhibit bit, or are you just displaying it?
I'm just displaying that. That's probably the only one that's displayed in the foreground without interrupts, so it's the simplest one. But the device, no, with the device select it won't actually know that it's selected a device unless the interrupt goes off, so it must be seeing something there. Unless it's seeing the output common instead of device select.
We might need the oscilloscope in some time, because we might be in signal integrity territory.
Well, let's get a dump of let's just dump out the state of something over and over again, and just make sure that at least communication is happening between the two.
Just figure out how to actually do that here. I'll have to go quiet for a few minutes to figure that out.
Yeah, I'm going to look through it as well, see if I see something that seems obvious.
If we just turn off interrupts, then we'll be able to just poll the inputs. Let's see if I can get you an example.
Could we just set so that if an interrupt hits, we just print a exclamation point or something on the screen?
We could.
Because an interrupt should hit when I do halt, ready, run, right?
Yeah, you should be getting device selects and output commons and all kinds of things.
All right, so whenever an interrupt hits, let's just put a little print in there that says print an exclamation point.
Down to bottom.
Down at the bottom.
Is there a way to ignore the one from status bit?
I don't even care that much about that, about ignoring it. I just want to make sure that we're interpreting interrupts. That'll tell us that our level shifters are doing their job.
Yeah, so in the function ISR device set common,
yeah,
then you can do serial.print and an exclamation point, see if that works. It can be risky to print from interrupts, but we'll take our chances.
Yeah. All right, let's just upload that. So I got another not ready.
What are you doing for time?
What am I doing?
Ready, run to...
Yeah. Go halt, ready, run. And I didn't see a single exclamation point.
And no device select common this time. No device select this time either. Well, we had to turn off and turn back on again to get that, I think.
To get the device selects, yeah.
Yeah, because this is the device select ISR. How are we doing for time? Must be getting pretty late there.
We're just after midnight. We got a little while.
Probably it's going to take me about half an hour or so of concentrating to make a better sketch.
All right, you concentrate. I'm going to pull the scope out and see if what our signals look like on the output coming from the Litton.
Okay, I'll be going quiet for a little bit.
And get the scope out here.
I'll be gone for a second too. The mention of the time reminded me that I need to go and re-up my cold medicine.
Oh, I hope you're feeling better, man.
I honestly don't know.
All right.
Last time I had the Rona, I was living on NyQuil for 3 weeks.
Yeah, that seems to be how it works. I lucked out. My whole family got the Rona 2 months ago or something like that. Everybody got it. Mickey got it. Both my parents got it. And I somehow managed to dodge it.
The first time I had it, it was like a bad cold, and it only lasted a few days. Then I got vaccinated, And then a year later, I caught it, and it was like 6 weeks long, and I lost my sense of smell and and sense of taste for almost 3 months.
Oof.
It was rough. I could taste a little bit of umami and salt, and that was it.
Oh man.
So it was like breakfast sausage was the best thing in the world.
All right.
Because it hit those receptors. It still tasted wrong. Everything else was like eating cardboard or wet cardboard. It was awful.
That's what I'm looking for right there. All right, let's see if I can do this without shorting stuff out. Battery power. All right.
Yeah, I've been really lucky. I haven't had any cold or flu or COVID since I haven't had any kind of anything like that since 2019.
Go on.
Yeah,
Chat.
I've been pretty well. I mean, it's partially because I'm pretty much a hermit.
My scope probe will probably work better if I plug it into the scope.
Yeah, that it would.
Wireless probes.
Yeah.
Works as well as wireless ESD.
All right, so let's see here. We've got some signals here. Let's see here. These are inputs from the Arduino. The Arduino shouldn't be inputting anything though, right? Or is it? One of those is held at 5 volts. Oh, that one's at 0. All right. That's at 0. That's at 0. Oh. That's at 0. Ooh, that one's gotten... Looks like it's trying to signal something. This is an output from the Litton input into the Arduino. It looks like there wants to be activity on there, but it's like super low, like the Arduino is maybe pulling it low. Which raises the question of... Yeah, that's like a... Let me get my trigger down there. It's like a full-on square wave, but it's just from 0.5 volts to 1 volt.
If we probe from the other side of the transistor.
So yeah, that's coming from the Litton there, which is also super low. This is the actual output direct from the Litton. It's like right around 0 volts. Not even like 0.1 volt to minus 0.1 volt.
That's before the first 10K resistor, right?
That's, yeah, direct on the connector into the level shifter.
Huh? That's supposed to be which signal?
That is the second from the right. There's an output on our control signals.
Okay.
It makes me wonder if my ground is chassis ground and signal ground are different, maybe.
Oh, that might be a case.
Oh, yeah, that's different. Certainly. Oh, because the Litton is going to be negative logic, right?
Yeah.
Yeah, there we go. All right, that's a good 0 to negative 12 coming out of the Litton. So Chassis ground and signal ground are apparently different. So now let's check the output from the Litton or into the Arduino, which is not signaling correctly. That's just going 0 to 1 volts.
Okay.
So.
And now the mean part. I think our transistors are not amplifying.
Don't jump to conclusions yet. Let's learn why that is the case.
Yeah.
Suss it out.
There should be one level of attenuation between the Litton and the transistor base.
I find a better place to flip on the ground. The ground keeps falling off. I gotta make something that makes clipping on the ground easier here. All right, so we've got coming from the Litton, I've got 0 to negative 12 volts coming in. That goes into this resistor, which then goes to the base. Now the base is at like some ridiculous level here. The base is right around 5 volts, going from slightly above 5 volts to slightly below 5 volts.
Yeah, that's to be expected, but we would be...
we may not be pulling low enough on the base to actually kick the transistor off.
Here we would be trying to kick the transistor on.
Well, you get what I'm trying to say, right? Like
in a way. Yeah.
Like the point that I'm trying to make is like what are the voltage levels that we should be seeing on the base? Because right now, would it help if someone visiting soon could help you with a second pair of eyes? Maybe. I don't know who wrote that. Or Drake. Yeah, maybe. I don't know. Is somebody visiting soon? I don't know if somebody's visiting soon. Certainly hope nobody's visiting. I don't have any plans. I'm kind of hoping to take the... Yeah, so let's see here. We're going from... Let me take a single shot of this. So we're going from the base of the transistor. The base of the transistor is going from 7 point... Let me line this up. Good Lord. Let me pick a value that makes sense here. So the base of the transistor is going from about 6.95 down to about 4.8. This is still like a terrible... Can't make any judgments from that.
Yeah, it looks not low enough.
Yeah, so how low does it... Yeah, so it's about 7 volts down to about 4.5 volts. But 4.5 volts should be enough to...
I mean, it's not 0.7 under 5.
You're right, it is not. It's not 0.7 under 5. Is that how low it's got to be?
I mean, silicon transistors normally take like something like 0.6, 0.7 volts forward. Sounds like something is floating. Yes, we're moving the signal weirdly. Just hope it's not the resistor selection from 256 bytes. Is he here right now? No,
Right,
doesn't seem so.
I mean, our resistor selection could very well be off. Yeah, so that's going down to that's starting at 7 volts and going down to 4.5 volt, which to me sounds like it's not going like low enough, right?
How's our 5 volts reference?
Oh, yeah, our 5 volt may not be 5 volt, huh? Hang on a second, let me check that. Here, I'll post the screenshot of this. I'm assuming you guys can also kind of see that on the camera here. All right, let's see here. Let's go run. Let's check our 5 volt voltage level here. I don't know where the heck it is. It doesn't, sure as heck doesn't look like 5 volts to me. Oh, there it is. Bang on, perfect 5 volts. That's not an issue.
I mean, with the amount of filtering and resistors they have in that regulator, it has to be 5 volts.
Yeah. Plus 18 is a little high. So plus 18 is actually at about 18.6.
Oh yeah, it does match what we were probing, I think, at some point. Well, I mean, there's one really good thing about it being 18.6. It's not 36.
Yes, it's definitely not 36. The minus 24 is right about minus 24. But yeah, plus 18 is slightly high. I don't know.
Oh. It used to be higher. Huh.
But that
used to be
shouldn't necessarily take it off.
19.67.
All right, so we have a case where we are like clearly seeing a value come into the transistor. Like this is very clearly 0 to negative 12 volts coming into our transistor here. Coming out of the transistor, we're seeing the transistor start to try and turn on, but it never actually turns on. Which definitely sounds like our base voltage here is not going low enough.
Yeah. And we're close enough to voltages that I don't think even flipping the transistor would matter. It's like, if that's not going low enough, it's not conducting either in reverse or forward.
Yeah. So what are our options here? I can put another resistor in parallel with the base resistor. And that would make the voltage level a little lower.
Yeah, that might be the easiest thing. Might need something fairly high.
Yeah, put like 100K or something in parallel with it to drop the 10K down to like 9K or something, right?
Would be in the right order of magnitude.
I mean, can we sim that right quick? Do you have the simulation of this thing pulled up? The spice?
Oh yeah, I did have a full spice of this.
Because I mean, if anything coming out of the Litton is, if all of the signals coming out of the Litton are only ever going down to 4.5 volts, none of the transistors are going to turn on, which means that the Arduino is never going to see any values at all.
Yeah, they might be. Some of them might be triggering more than others. I also have to think that probing it is not in the order of magnitude that it's affecting it.
Oh no, my probes are in 10x mode as well, so.
Yeah.
But if I remember the level shifter schematic. Oh, jeez. Oh man. So if I remember our level shifter schematic, we're essentially building a voltage divider right on the start there, right?
Yeah, a voltage divider. It's a voltage divider, but there's two voltages. It's like, I'm not a huge fan of that
Right.
technique
So
because I don't know how to.
Yeah, we've got the 10K coming in from the Litton, and then we have a 10K to plus 18 and a 4.7K to plus 5. So if we drop the value of the 10K, that'll shift the whole base value lower. If we drop it too much, the transistor will be on all the time. So there's like a fine balance that we're going to have to strike here.
I mean, it's many. You see it all the way up to like what, +7. You have at least 2 volts there.
Yeah, we got a little bit. So what is? Oh man, I'm so bad at parallel resistance calculations. Let's go. Parallel resistor calculator. So I'm just going to go off of like a gut feeling here. So if I do a 10K and 100K, the equivalent resistance is 9K. So I'm just going to parallel 100K on the 10K resistor of this one signal. So I'm just going to pop the board out, parallel 100K on that. We'll pop it back in and then check it with the scope and see what changes. And if that suddenly that signal is starting to come through, then we'll go through and change that on all the other inputs.
Yeah, let's debug one.
Yeah, Thordrake, the oscilloscope definitely has well more than 2,000 times the processing of the Litton.
I'm not entirely sure that order of magnitude covers it.
Yeah, it's probably more like 2 million times or something like that.
Yeah.
If you consider the FPGA that's doing the memory shifting.
Yeah. All right, so I think we may just like be slightly out of the spec of that transistor right now. So we're just gonna slap 100K on there, recheck it. I got a bunch of 100Ks, so I hope that's the value that we need. All right, I'm warming the soldering iron back up.
Yeah, in the simulation, it was going 6.93 volts to 4.25.
What are those? Those are Phillips. It was going to what? 4.25?
Yeah, it might have been way too close for the precision of our voltage inputs.
Yeah. So we were, it's a little off. No big deal.
I mean, with an ideal 5 volts, an ideal resistor, an ideal +8... Oh, too many ideals.
I better mark these. All right.
Oh yeah, even in the simulation, if we bump up the 18 volt to 18.6, it's not fully turning on the transistor.
So okay, I bet you that's what it is. I bet you our 18 volt rail is just slightly too high, which is causing the transistor to not turn on all the way. So if we drop, if you take the simulation, leave it at 18.6, but drop it down, drop the input resistor down to 9K, what does it do?
Well, I'll try adding a 100K in parallel.
Yeah, you can do that.
If I can zoom in a bit.
Tell me if my gut feeling is on point here or not.
Adding a 100K seems to work.
Let me make sure these are actually 10Ks that I put in here. Now I'm curious if they're not.
Can you just replace a few of them first to see if it works, or are you going to replace all of them?
I'm just going to replace one. I'm not even going to replace it. I'm just going to parallel one, and then we're going to put it back together and test that single bit, because we know that that one is twiddling. So that's going to be our test bed. And then if that brings it back to life, then we'll figure out how to do, then we'll sit down and do the rest.
Yeah, your gut feeling is right. 100K above a 10K is now 9K.
Well, I mean, my gut feeling on the value, I didn't know, but the does it make it work? That's the big thing.
Yeah, well, the voltages weren't going low enough. The problem is
Did you not
if
sim
it
it
was if it was going lower than 4.27 or 4.24, we wouldn't see it.
Yeah. Well, what does the simulation say?
Well, the problem is once you get too low, the transistor is going to feed back some of its electricity and keep it up, because it's going to keep it exactly at 0.6, 0.7 of the 5 volt rail. So
Yeah, but I mean,
if you go, yeah.
When you simmed it with the 100K in parallel, did the transistor fully turn on?
Yes.
Okay.
Up to 4.92 volts.
So it turned on hard. That's good. Poor Reese is going to be looking for a bug in the code that doesn't exist.
So
That
now
was
if I...
the story of my life.
it's always the same thing. When you search in software, it's always hardware.
Yep.
It's always the other one.
Yeah. Now,
So
no
you check the
guarantees
other one first.
No guarantees that what's
Is it?
coming from the Arduino is good too. So we're gonna have to figure out a way to test that as well. But let's start with trying to get the Litton to communicate to the Arduino, and then we'll work on going in the opposite direction. All right. So that one is now doubled up. Let's put it back together and give it a test.
I just dumped a sketch in the chat that just turns off interrupts and just dumps the raw signal transitions. So hopefully that helps.
Okay.
So yeah, if we're seeing 4.3 volts on the base, and we're still seeing 1 volt on the output,
Yeah, then we know we got a bigger problem.
Then we have the problem that the transistor is backwards. But we'll see. The simulation gives me just 1 volt output.
Oh, if you put the transistor in backwards?
Yep.
Oh.
It goes from 8 nanovolts to 963 millivolts.
I need a pair of hemostats.
Oh yeah, those would be useful.
What drawer are they in? There they are.
Maybe it's Gremlins.
No, I'm pretty confident that we're on the right path here.
It's clear it's the voltage levels.
I mean, yeah, the scope doesn't lie. The scope was clearly showing us that the transistor was not turning on.
The signal wasn't getting there.
Yeah. Do it in this corner, I guess. Yeah, us hardware guys, we tell the software guys to go search for a bug, so it gives us time to find the actual problem in hardware.
And the software guys go to the bathroom so they can have peace and quiet and think about it.
Yeah, the software guys are go, I know it's a hardware problem, but whatever.
It don't matter if it's hardware or software. We're still going to be told to fix it in software.
That's right.
Yeah.
God, I wouldn't.
Unfortunately, yes.
Unfortunately, I don't know how I would.
This one you can't fix in software. This one's got to be fixed in hardware.
Like, use the analog inputs. What?
As a famous hardware engineer once said, answer that. It might be the phone.
I don't. That one went over my head.
That's a quote from Tony Walks, who did a bunch of PDP-10 work, but it's quoted at the beginning of the famous hardware/software engineering horror story, Tony and RH20 Land.
All right, let's go. I need to hook you onto the base of this guy right here. All right, so let's go power on with the Litton. All right, let's go. Alt, ready, run. So we do have an input coming into this thing. My scale is all sorts of broken. That's going down to about much lower. So let's check our output now. It's not great. So our output into the Arduino is looks like 0 to 2 volts. 2 volts is weird.
Yeah, 2 volts is weird.
All right, what is the actual input to the base look like here? bring you down a bit. Trigger still may not be, well, I don't know. So that looks like just slightly under 7 volts to slightly under 4.5 volts. Now, I don't know if that's like the transistor is turning on, so it's holding it at that level. This still feels like we're not going low enough. Like maybe 100K was not big enough, or maybe 100K was too big.
Yeah, they would wager on the too big.
Yeah, so yeah, that's a terrible photograph. Try that again.
I think we're editing the right resistor at least.
Yeah, I think we're barking up the correct tree. We're just not getting just off on the value.
Like, at some point, we're gonna turn on that transistor, whether it likes it or not, whether it's in the right direction or not.
Yeah, so what if we do, like, what if I do a 10K and a 33K?
I mean, next step would be something like
That drops it to
47.
Yeah, I don't have any. I got a bunch of 33Ks. That drops it to 7.5K on the input. And we've got 7 volts. So we're like a full 2 volts above 5 volts. Like if we're just even slightly above 5 volts, the transistor turns off. Right. So we got a ton of room to play with there. So let's try a 33K. I think a 33K is going to get us headed in the correct direction. Because we did see a definitive improvement here, 0 to 2 volts as opposed to the 0 to 1 volts that we were seeing. So the transistor is starting to turn on, but I don't think it's getting all the way there. What's up, KE7845? How you doing? And I can swap that 100K for a 33K real easy.
Hey, Dave, I'm signing off for the night. Have a good night.
Take it easy, Bob. Thanks for hanging out.
On the positive note, if you put a 33K there, it might turn on even a reverse polarity transistor hard enough that we can read it.
Well, I genuinely don't think our transistors are reverse polarity, though.
Because I'm seeing like over 2 volts on the simulation now.
Yeah, 256 by RAM would be having a full-on panic attack if you saw what we were doing.
I mean, the transistor works backwards, it's just less efficient. It amplifies a bit less. .2 is enough to be recognized as high, right?
I mean, we're pretty close The Arduino almost could recognize that as a proper high level.
I know it's in the metastable section, but what does the Arduino know about metastable stuff anyway?
All right. Back into the Litton. And then if this works, we'll just go through and add 33Ks to all of them. Great. And that's all of them. That's like 13 that we would have to add to it. That's a lot.
Yeah, the Twitch chat was weird because it cut the start of the name of Spike 7845.
Oh, it didn't cut it. I've just got my windows messed up incorrectly.
Oh yeah, it's overlapping. Yeah.
Yeah, there we go. Did I call him KE7845 or something?
Yep. But
Yep.
You got the significant digits.
There we go, yeah. It was close enough. Close enough for government work. Oh, come on. Plug in. I hate parallel interfaces. It's just so many wires in such a tiny spot. There we go. Okay, that's all plugged in. This time I'm just going to go scope straight onto the output out of the transistor.
Serial interfaces were a big problem with the other one, the PDP, for a while.
Well, serial interfaces have their own problems, but if I'm making something from scratch,
please, there's less wires.
3 wires sure is nicer. All right. Litton coming up. Yeah, sorry, Spike 7845. I still got it wrong. Spike 7845. Yeah, I got my windows lined up a little better now. All right, moment of truth. Halt. Ready. Run. Look at that. 0 to 3 volts. That's almost there. I thought it was 5 volts at first, but it is not.
I think we're going to leave the question of are they the wrong way around for a while and just add some resistors.
Yeah, Val. 3 volts should be enough. If I plug in the Arduino, I wonder what the Arduino sketch is saying here.
It's on one of the signal lines, right?
Yeah, this is one of the input lines.
Yeah, so it should be screaming out, screaming out like the exclamation mark or whatever we put into the sketch.
Yeah, so I got it not ready.
It should be screaming a lot of them. So I'm seeing.
That's almost to 4 volts. That's like 3.8 volts.
Yeah. So I'd be asking, what's the beta on that transistor in that direction? Anyway, yeah.
I mean, it's a lot closer. What's the
We'll post it. We'll post the output. Like, take a screenshot of those output levels, and we'll ask him next time he looks into the Litton channel. It's like, are these fine?
here? Yeah, if I look at the bring this waveform way up here. If I look at the base now, it's like 6.5 volts to about 4.3 or 4.2.
Yeah. 4.3 and between 4.3 and 4.2, you'd be like turning it on completely. It's like the full 0.7 volts.
Yeah, so the transistor should be turning on.
The problem is you don't know how low that technically goes, because at that point it's the transistor that's keeping the signal clipped.
So the next question is our 1K ohm pull down to ground too tough? Like, the transistor should be able to outdo that pull down to ground. We're not getting any exclamation points. Although I feel like we should be. Because this thing is this is the second from the farthest right. So it would be this as far as the IO signals go, it would be the second lowest one. Let me see if I can.
Either it's going to be KD2 or K150.
No, it's going to be K82. Yeah, so whatever K82 is.
Device select common. So all the device selection should be there.
I'll take it easy, Balsh. Yeah, so does K82 hit an interrupt, or does that go someplace else?
It should. It's the one that's telling you which address is getting selected. So it should be hitting a lot of interrupts. Slightly strange. 3 volts is plenty. I mean, it's...
Yeah, so at this point, like, I mean, I'm seeing the input into the Arduino. If we look at that, I mean, it's a little... I would have loved to have seen, like, a hard 5 volts. Come on.
Are we seeing slightly above 3?
I'm trying to hook onto it to tell you, but I can't. I can do it here, I think. No, you're gonna be way back there. So yeah, we're seeing, take a single shot here. .5 volts per division, yeah. So we're seeing a low of 0.5 volts and a high of 3.7 volts.
That should be hitting it way enough.
I don't know about way enough, but it should be enough for it to register.
I'm so used to 3.3 volts levels.
Yeah, about 3.7 volts.
Yeah, why did we even put transistors? We should have just plugged it straight into the Arduino.
All right, so the real question is why is it only getting to 3.7 volts? Why are we not getting a hard 5 volts? I think if the transistor's backwards, we wouldn't even be seeing that. I don't think we'd be seeing 3.7 volts if the transistor was backwards.
This simulation does make it work. Even if it's backwards.
I mean, I can desolder the transistor and flip it around. We can see what happens.
I mean, if it goes way better, we have a good idea what's happening. If it's going the same or a bit worse, well, no, it's going to be.
Hey, question. This is pulled up to 5 volts on the Arduino side, isn't it?
Pulled to ground.
Oh, okay. Pulled the other direction. All right.
All right, well, if only to get Roy to shut up about the transistors being backwards, I'll flip it around.
Yeah, why not?
Because I'm pretty sure we loaded the datasheet for the inverted kind of transistor for that one.
You've said it like 18 times at this point, so we might as well just appease you. All right. I think I can do this cleanly.
Also, the name of the critter was Mogwai, not Mowgli. Mowgli was the kid from Jungle Book.
Isn't Mogwai isn't that like a new metal band? Who am I thinking of?
No, wasn't it Gizmo? The species was Mogwai.
Yeah, just feed them after midnight and they turn into gremlins.
Yeah, it was feed them after midnight or get them wet or something else.
And get them wet, they shoot out babies. Feed them after midnight, they turn into gremlins.
All right. It sure is going to look funny with one resistor turned around backwards. Or one transistor turned around backwards, I mean. If this is it, I'm going to be moderately angry.
So the question won't be if you turning around makes it go down to ground. It's whether or not turning it around makes it come back up again when it's supposed to.
Yeah, I'm expecting by turning it around for it to just not twiddle at all. That's kind of what I'm expecting to see. But that was a rapid change that we could make. To make life a little bit easier. This will be a sanity check, we'll call it. This is a confirmation that I'm not terrible at my job. or confirmation that I am terrible at my job. One of the two. Confirmation either way. Also, we should have just made it out of vacuum tubes. Then I wouldn't have gotten it wrong.
Because then it would take up a lot more space.
It'd be a little hotter too.
Yeah.
I mean, there's a fan in the Litton. It's fine.
So using 1950s tech to interface a 1970 computer with a 2010 computer.
Yeah.
Much like Back to the Future.
I mean,
That's
it's
right,
the
yeah.
right type of transition. It's like if you want to make everything more towards the same number, like it averages out to the right age.
We've seen Usagi's tube 5-5-5 timer.
Yeah.
So
Don't threaten me with a good time. All right. Let's see. Let's go run on you. All right. Litton coming up. All right. Well, it's very cleanly sitting at 0 volts, if that means anything. Not 0 volts, about half a volt, I should say. All right. Halt. Ready. Run. Oh, God damn it.
Did that fix it?
Yeah. It's like a hard 5 volts.
I mean, we did the error by Google's default. Google gave you the wrong data sheet.
I mean, I'm still not getting exclamation points in the sketch.
Okay, so Reese still has problem on his end.
Maybe I put the print exclamation point in the wrong spot or something.
Maybe switch to the other sketch.
Huh?
Sorry, maybe switch to the other sketch, which just dumps the raw signals.
Yeah, I can do that. I mean, we should only have one good signal, apparently. Let's see here.
At the same time, would we have the right voltages to run tubes? It's like,
I mean, sure. I ran tubes on incredibly low voltages.
Not quite this low, though.
I mean,
Almost.
we have access.
I did plus 24 volts and negative 12 volts. You've got negative 24 volts on here. You've got plus 36, so you actually have more than I had.
Okay.
We need to pick the plus 36 somewhere else because it doesn't go to the card. But I mean, that's not a problem.
All right, so
problem would be scale.
What am I expecting on the serial monitor here? K83 status or data is high, low, high, low, high, low, high, low, high, low.
Okay, can you screenshot that or?
Yeah, I mean, it's just like constantly scrolling K83 status or data is high and low over and over and over again.
Is the Litton running or is it halted?
It's running.
It's KV3. Right?
Is that the pin that we're working on?
No. It's KV2 we're working on.
How come nothing else is printing?
Might want to make one small change. Uh,
Oh, that's a terrible picture. Good lord. Okay. The Moire
As far
effect on my phone is insane.
As far as low voltage tubes, don't forget they made little bitty tubes that went in pocket size tube radios that ran on, what was
12
it,
volts.
9 and 18 volts?
There was a bunch in
'Cause
cars
they've
that
already-
ran on 12.
Yeah, that's true too. Yeah, those were
All right.
pretty big.
Reese, what's the one change you want me to make?
okay, I just posted in the chat. Up in the setup, just want to flip the state of output busy. See if we get it the other way around.
That
We might have trouble with output busy.
yeah. Here, make the output not busy so Litton can send us data. Change this to L high. What line number is that?
It's on line 222.
Good lord, okay.
Yeah, Reese, the problem is his output busy right now is probably not switching much.
Yeah. I'm just curious if we flip that, whether or not it's going to wake something else up.
Would wager it's not going to
Nah,
be
it's the same
pulling
thing over
it
and
up.
over again. It's still
Okay.
K83 status or data is high or low.
It's
High, low,
probably
high,
not
low, high,
pulling
low.
high enough.
Yeah, I'd say you're going to have to flip all those transistors.
Yep. That's gonna suck. I gotta do it on
How
both
many
boards too.
transistors will that be to flip?
22?
Yeah, 20 something.
I did remove one.
Yeah. All right, so we'll flip them, and I don't think we need to parallel. I don't think we need to parallel anything.
We might not need to parallel anything,
Yeah,
but
so
like we'll do
Yeah,
that.
that's maybe
second
something to
step
try
after.
first. To just take your resistor off and see if.
Yeah, probably a good idea.
well, I'm getting tired of unplugging and plugging this thing, and I know that the transistors are backwards, so
Yeah, batch work. Hmm.
yeah.
I mean,
Let's get you completely out of the way here. All right. You go up top. I can get that. That's easy enough. I gotta mark the ones on the bottom. I think they are marked, maybe. Yep, those are marked. All right. I mean, I really should go to bed, but I kind of want to see this bitch work. I think I can speed run this.
Those were 2N270
something or other.
Yeah. I'm sure it must have it in the history.
I'm gonna run out of solder braid here. I got an Amazon order that's got to go in tomorrow.
Is this worth firing up your desoldering iron?
No, I don't think so. These single-sided PCBs don't have plated through holes, so the braid does really good on them.
True.
If they had plated through holes, absolutely, I would be firing the desoldering iron up on. But I mean, I've had to desolder and move a bunch of stuff around on UE1 before. This all seems to work decently well. There's one. There's 2, 3, 4, 5, 6. All right, let's flip them around. I'm just going to reuse these same transistors. I think they're probably fine. Can't imagine that we hurt them.
We didn't go far enough to hurt them. If we did, they've been naughty transistors.
Let's got a little bit of solder on it. So if we were smart, we would have tested one of these. We would have soldered one up and then tested it. I'm not smart.
Why am I unable to copy paste? Damn.
Gang, Texas's power demand is up 5% year over year to an average of 372 terawatt hours.
Dang.
A lot.
What are we using it for?
Data centers.
AI and crypto.
That makes sense.
Must be the. This is the most ridiculous thing to do. Why put data centers in places where you need AC?
Well, they have DC.
Yeah.
Well, somebody's quick on the draw tonight.
NVIDIA has designed an orbiting space station that uses containerized H100 AI nodes in space.
Which would make the thermals a hassle because space doesn't do conduction.
Exactly.
You do the same thing they did with Apollo. You rotate it.
That was to stop it from heating up from the sun unevenly. That wasn't to help it cool down.
Yeah. Getting rid of heat is as much of a problem in space as heating up.
What do they do with the cooling water on Apollo? Did they just dump it?
They didn't have cooling water. In in the command module, in the service module, you had a glycol loop that ran through a heat exchanger, and since we needed a lot of heat to keep the fuel cells running, it tended to use the heat that it made to keep the fuel cell reaction going. The lunar module didn't have fuel cells; it had batteries, and so it was cooled by sublimation. There was a big block of ice, essentially, that was allowed to evaporate out into space, and the evaporation took the heat energy with it. But that's why the coolant loop in the LEM was only good for some number of hours once the loop was operational. And I don't remember what the number of hours was, but there were a couple of reasons like that. The LEM was lifetime limited, and the lifetime clock started when it disconnected from the umbilical at launch. So,
gotcha.
So same way the the space station?
No,
Radiators.
the space station has a radiator system. If you look at the trusses on ISS, there are flat panels that are 90 degrees out from the plane.
And they use ammonia.
Yeah, it's an ammonia loop. But there's things that look kind of like a solar cell, but they zigzag and they're opaque. They don't reflect, and they're 90 degrees out of plane with respect to the orbital or the solar arrays. Those are the radiators.
And they try to keep in shade from the solar panels because that's a nice shady place to put them.
Yep.
Ammonia is a great refrigerant. Just doesn't do well when it leaks.
We when I was growing up in Wyoming around 1990, we had an ammonia cycle refrigerator that was built in in the mid 1940s, and it still worked perfectly.
I grew up with one too, and it's still used in a lot of food packing plants and like ice skating rinks.
That's because all the things that are horrifically unsafe for you work amazingly well.
Well, there's a lot of, if you buy a new fridge now, chances are it'll come with, I think it's R290, which is not a great refrigerant, but it's also propane.
Basically, yes.
Isobutane, propane. It goes boom if it leaks.
The problem now is that if you buy a new refrigerator, it comes with like Wi-Fi and Bluetooth, and then that shit invariably breaks, and then you have to call the repair guy out because your refrigerator won't keep things cold because it lost its internet connection.
Or worse, they decide after purchase that, hey, that screen on your refrigerator is now going to display ads continuously.
Yeah.
When I moved in here 11 years ago, I followed the rule that you buy a refrigerator that's been in production for at least 5 years and is one step up from the lowest model in that size they make. And it still works perfectly today.
Don't buy an ice maker, don't buy a water dispenser, and it'll last a long time.
Yeah.
It's a Frigidaire side by side. It has the traditional mechanical ice maker and the solenoid operated water in the door with just a regular loop of plastic tubing in the refrigerator to cool the water, and it works just fine still.
That's the Reddit website, buy it for, or the subreddit, buy it for life.
Yeah.
Those guys are obsessed with socks.
All right.
Whenever I go on there, there's posts talking about which socks don't wear out.
It's like a legitimate concern, man. I go through socks at an alarming rate.
You gotta
SA
like
had the same kind of thing on SA. It was called coupons and deals, and it was the only justifiable reason to buy access to that website.
You know, what I discovered with my socks is that wearing the socks with sandals wore holes in them very quickly, but wearing them with shoes doesn't have the same issue.
I go shoeless a lot. That's why I go through socks pretty rapidly.
Same. I don't wear shoes in the house.
With the added bonus of you're constantly cleaning the floor.
I wear an orthotic kind of sandal around the house. I need the arch support. I have high arches.
No, see, up here, the big deal is they salt the roads and the walkways and stuff in the winter. So if you're wearing your shoes around the house, you're tracking road salt around the house.
Road salt
shoes.
Road salt is evil. I had a Honda Element that I got that was from Ohio, and it has rust through the floor in places, but at least the frame was intact.
I do actually, though, have essentially old shoes that I wear in the house that I don't take outside because, yeah, the salt is horrific.
What's funny about the Element is that Honda recalled them for salt damage and repaired them in Canada, but not in the United States.
Hmm.
And considering they were all made in the United States.
All right, so flat side facing.
What is the deal with the metals some of the companies use, like Toyota in their frames? Holy shit.
Yeah, they use special high strength steel.
Yeah, Chevy.
Why do they rust so fast?
Chevy truck frames are horrible in salt areas. They rust out and just disintegrate. Especially the tube that goes across under the bed of the pickup.
Cross member?
Yeah, those tubular cross members just rust right out of like the 2000 to 2010 Chevy pickups, GMC.
They had there was a recall on the Tacomas, which they actually were replacing frames for a number of years. I hear fluid film is actually a good way to waterproof before the winter, and unfortunately, I haven't been doing it.
I had a couple of AMC Eagle wagons, and they had Z-Bart protection on them, which was basically heavily galvanized steel.
Oh, Pentium has one of those.
Great car. It was basically the first crossover, SUV drivetrain under a car.
Yeah.
I had a 2005 Jeep Grand Cherokee, and it was the exact same size. The wheelbase, the interior size, pretty much. The exterior dimensions were almost exactly the same as an Eagle wagon, just a little taller.
Mm-hmm. But did it have a desert only mode on the air conditioner?
My Eagles didn't have that, but then they were from Montana, so that may have been a California, or Southern Desert only thing.
It depended on the year. I think the earlier ones had it. It was more they were concerned it would ice up the evaporator if you weren't in truly dry air.
But that viscous coupling differential was really nice. I had a Subaru WRX that had the same kind of viscous coupling systems, and a BMW 325iX in '89 that also had that. Great cars in the winter.
It didn't work worth a damn. It just pulled all my transistors out.
Oh no.
Well, I was trying to use a piece of tape to hold them in because, the transistors are not the tallest thing on the board now.
And your leads are already pre-trimmed, right?
Yeah. So I was trying to use a piece of tape to hold them in place, and that didn't work. Try again here.
Just shove a ruler or something underneath them to shim them up.
Yeah, it's going to have to be something really big because I've got the mounting studs still on this thing.
My experience with rust on Dodges has been the wheel wells and like the rear fenders of the bed rot. But the structure of the truck, the frame, doesn't rot out.
A guy I worked with had an old 300 convertible, or we're talking like a 90s car. The filler neck rusted out on his gas tank.
Okay.
He found that he didn't realize that until he was about 3 gallons in.
Oh, that's a big puddle. Yeah, the Honda. Actually, I had to replace the filler neck on the Honda Element. It was an 03 Element. This was in 2021, and I had to replace the filler neck because it rusted.
I think one of the guys on RTC had a Element.
My nephew has it now. I sold it to my brother-in-law, and he ended up giving it to my nephew, and it's still going great. I got it cheap, and I suspected it had a blown head gasket, and it did. But it turned out not to be that big of an issue because that K24A1 engine that it used was the same as the Honda Accord. And there was an outfit in Sacramento that imported them from Japan. Because evidently in Japan, they break up cars at 100,000 kilometers because there's like an expensive reinspection. And so common vehicles just get wrecked, get broken for parts.
It has nothing to do with the mileage. It just has to do with how old the car is. And inspection is expensive as shit anyways in Japan. Like $1,000 pretty much. And you have to do it every 2 years. Or if you buy a new car, you get 3 years free inspection included with it. So this was their way of like stimulating new car sales.
That makes sense.
Yeah. So the older the car gets, you're paying $1,000 or more depending on where you're getting it inspected at and what all needs to be. So like $1,000 is pretty much just like the inspection. Like if something needs to be replaced, you got to pay on top of that, right? And so there's this whole economy based around like you're already making monthly payments, on your slightly used car, that you bought new is now 3-4 years old, and just continue making monthly payments and you never have to worry about inspection. Because, just upgrade to the newest car and you never have to worry about inspection and your monthly payments won't change. Yeah, that's effectively what it is. It's like a lease. It's their way of stimulating it. But it means that people that want used cars, they're looking at, you look at the price of the used car and then you have to tack on an extra $1,000 plus just to get it on the road, right? So if somebody's selling a used car for $20,000, that used car is actually, $22,000.
I assume if you flunk the inspection, then you have to pay for the fix and then also pay for the reinspection.
I think so. I don't know. I never owned anything that flunked the inspection. Partially because we had all of my cars were classic cars, and they're real lenient on classic cars. Like they're not lenient on old cars, but they're lenient on classic cars. So it's an important distinction to make there. But also, we would always get our family friends to go do it who ran the local classic car shop. So like I still have the car. It's a Mitsubishi 360. It went to go get an inspection, and the tail shaft seal on the back of the transmission went while she was driving it to go get inspection. And the entire bottom of the car was just coated in transmission fluid. And they went to go get it inspected. And the lady looked at it and was like, this is a lot of transmission fluid, which should fail the car. And Chiho was like, yeah, we run a shop called Classic Car Nagoya. The part didn't get in time, but it comes in today. And so we're just going to change it tomorrow. Like, total lie. And they were like, okay, that's good enough. It's great.
Yeah. This was interesting because I live up by Reno, and this outfit down in Sacramento delivered the complete Honda Accord engine, long block, complete with starter and alternator, for $800 delivered, paid shipping, everything. It was a great deal, and it had less than 60,000 miles on it, and the car's still running great. My nephew loves it because of the rubber floor, because it's easy to clean out.
Oh yeah, I like the way the seats fold up on that too.
What's he doing that he needs a rubber floor? Was he Dexter?
No. The Element has a rubber floor.
I know it has a rubber floor, but why is that such a big deal? Is he
they have
murdering
dogs.
People? Oh, they got dogs.
No.
Okay.
Yeah, they've got dogs and the mud and the fur. It's easy to clean up. The biggest issue is some people think you can hose them out, which you can't. They're not a Jeep Wrangler. They're not designed to be hosed out. But
all right.
I love my Gen 1. Sorry.
Oh, you can go ahead.
Oh no, I had a Gen 1 Honda CRV, and it just had so many like nice little features, like the picnic table onto the where the spare would be. The seats would fold flat into a bed. They did a lot of little niceties.
The Element had the same things. There were legs for the cover over the spare tire in the back, and you could fold flat the front seats and the rear seats, and it would make just a huge bed. The other neat thing is that you can with the Element you can fold the seats up to the side or remove them completely from the rear of it.
The Element was all-wheel drive too, as well, right?
Yeah, well, it was all-wheel drive or front-wheel drive. The one I had was all-wheel drive and had ABS brakes, which made it hard to find rear knuckles and hubs for. The bushings were completely shot in the rear knuckles, and I tried to buy used rear knuckles, and they turned out that they lied. They weren't ABS, and so they were just junk. But I took it into Les Schwab, and they had a fixed price on their list for replacing those bushings, and so I was like, "Here, replace the bushings." And that 2-hour job, 6 hours later, they came in and they're like, "It's done, and we don't want to see it again." But it fixed the issue. The biggest problem with the Element is driving at long distance, because you're driving a tin box.
What's going on?
It is noisy.
I'm reminded of the old Oshkosh, probably apocryphal story where, or no, it wasn't Oshkosh. It's somebody's unnamed local air show. They get suckered into agreeing to take a bunch of kids up on a Young Eagles flight, and as they are leaving the ground, they ask the air show controller, "Hey, how long am I supposed to keep them up for?" And the answer he's given is usually until the second or third one throws up.
All right. Because it's late, we're just going for broke. I'm going to load up the other sketch that was just like the to use it sketch.
Are you going to put back the change to the negative logic as well?
I don't know the answer to that.
Or maybe you made a change to the first sketch to change from negative to positive logic.
Yeah, I think I changed that back right off the bat. So right now I've got L high is 0, L low is 1.
And the rising falling?
Yeah, L rising is falling.
Okay, let's back to the original.
Okay, so I'm going to upload this. And then I'm going to run Minicom, actually. Because the text is bigger. All right, so it says not ready, but, it should say not ready. Because the Litton is off. All right. That should be somewhat readable.
Release the hounds.
Yep. Now the Litton's spinning up. We don't have a ready light, so I'm not expecting anything to happen anyways.
Oh yeah, it would be non-ready because it's 0 volts.
Oh, we got it ready. We got ready. It says ready.
Holy dilly.
All right. I'm going to do halt, ready,
halt,
run.
Ready, run.
Halt, ready, run. Oh, I still got my exclamation points in there, apparently.
Well, that means it's working. Let's take those out and get it go.
Okay. Let's go.
Oh, you selected the right devices as well. C04941. Those are the correct device IDs. We've at least got the Apple bits around the right way.
Okay,
all
I
right.
told you polarity was good, and I told you bit order was good.
All right. You get 3 more I told you so's, and then I'm kicking you out.
No, that's for Reese. That's for Reese.
Okay, whatever. Oh
All right,
thank God.
where did I put that at? What was that? 222 or something?
No, it's down the bottom. Hang on.
I'm just
Might do
happy
the
you
number.
don't have to flip them all back.
I got it. There it is.
Yeah, right about line 630 something.
Yep. File. Let me resave this.
I find it
Upload.
slightly odd that pressing the ready button on the Litton didn't show up inhibit again. Might
All
be
right, now
too
what?
short.
I can.
I'm just waiting
I
for
can
the
halt,
stream to catch up.
I'll halt, ready, run again. And you got a whole bunch of device selects, C0490, FF410.
Now, the FFs and the zeros aren't normal. But, yeah, hit the N key.
Nada.
Okay. Yeah, you should have seen it like a carriage return and a line feed as well. So I'd say the outputs. Yeah, because the device select, because the last device that was selected was 0, it's basically the sketch is ignoring the output if there's any at the moment.
Okay.
Just do halt ready run again. See if we can clear that.
Looks like same collection. No, it's a different collection. Now it's 403D0FF410.
Yeah, I think we still got a little bit of noise on the signals because that 3D should definitely not be there.
Yeah, we might still need to add like 100Ks or something like that to.
But this is good. We're getting close. I'll just give you a quick patch. I'll just see what that to just make it just do outputs regardless of what the device selector is doing. Hang on, let me find it in the code.
Okay.
Because right now it only looks at the output values if the device select matches, but we can disable that. Hang on.
Actually, before you change the sketch, power down the Litton, give it a second, and power up again, and see if it behaves, because it seems weird to me that it behaved exactly as it should for that first power up with the exclamation points, but then everything went to pot when you are reloading with it powered up. I wonder if there's something going wrong with how initial state is determined.
Yeah, I can try that.
Because
It's going to take
when
a
it
second.
starts up, hold on. Okay, when you're using the edges to detect things, are you synthesizing rising edges on things that are already high when the software starts up?
Probably assumes it's either high or low. I forget.
It's going to take it a second. It takes a while for the drum to spin down.
Yeah, I know. I figured they'll take about as much time as it's going to take to make the patch anyway.
The hilarious part is the Litton actually waits for the correct drum speed.
Well, yeah, because otherwise its timing would be all wrong.
I mean, yeah, the 100 nanosecond would be wrong, yeah. There's only one hard delay in the whole thing.
And I bet that hard delay is based on the drum rotation time, isn't it?
More or less. It's 100 nanosecond.
It's still spinning down, by the way.
Yeah, we can sometimes hear it in the background.
All right. Coming back up. You had some device selects right off the bat there, but I think that was just chaos. You had a device select of FF and 0, but the system isn't ready. We got a ready light. We got ready.
You got a tab out of somewhere.
Yeah. That was on like when I first turned the power on. So I think it's just like chaos coming into this thing. All right,
Yeah,
so
I just thought it was
halt,
weird that it
ready,
typed out.
run. There you go. That's what you get. You get C0490400FF410.
Those. It should be mostly just C049 and 41. The others. Anyway, I just put a patch in the chat. Let's just give us a quick check. We might have to have a think over the next week as to how to diagnose this.
I mean, this is good news. Like the
yeah, it's doing something, and the fact that we're getting 49s and 41s in there shows that we actually have the bit order around the right way, because those are the C04941. They're expected, so we have the bits in the right order for the output at least.
Would it be possible that we're like seeing a transition on the as an address, but it's actually data?
Okay. I think I can do this. 6. Boy, I'm tired. 629. Okay.
Yeah, so in that condition, just at the start, just put true and 2 vertical bars. That'll just make it always take that case.
I gotcha. Okay.
That's it.
I'm going to go back to this because it's just easier for me to read. And then we'll do a halt, ready, run again. Halt, ready, run.
So if it gets any output bytes at all, it should try to dump them.
Yeah, you got C0490FF410.
There's a carriage return line feed there.
There is a carriage return in the middle there.
That's what. Did you do the halt ready? Yeah, you did the halt ready run. So that's Opus maybe printing out a new line. So it might be alive. Except that now we have to disable the input the input type I select. I forgot about that one. I think it's working enough that we can say we're getting some data out of this.
Okay. Well, if you got a quick patch that I can do that to make it so that input does something, I can do that right quick.
I was just going ahead to just say, oh, let's just go for broke, but apparently you need to do it in smaller steps.
Yeah, Genocide, it is well after midnight. I should have gone to bed 2 hours ago, but it's a little exciting. So, all right, you got a rapid patch for me? Please tell me you got a rapid patch for me. Oh, you do. Excellent. Line 319, same thing, if true, right?
Yeah.
PRUE, pipe. That's it?
Hope so.
Just on line 19, huh? Okay. Let's upload that.
And Twitch decided to give me an ad. Fantastic.
Excellent. Quick, everybody, make it do special things right now. I mean, there's like probably a 10-second delay, so. All right. Let's do a halt, ready, run. Halt, ready, run. Again, you got C049040 carriage return 0FF410.
Press N for number.
That put the cursor on the other side of the screen.
Okay. that's so I think the input bits might be around that way. P.
Now the cursor, yeah, P didn't do anything. The cursor seems stuck. It's not even flashing anymore. Let me halt ready run it again. Okay. I'll try P. Nothing.
You may need to turn on auto word wrap and minicom.
Oh yeah, I might be doing that. Let's go Control A, Z. How do I get it set up?
I think you want Control A, O for options.
Okay. Yeah, there we go. Screen. Line wrap. Let's change that to yes.
Yeah.
All right, let's alt ready run it again. Alt ready run. Still all the way on the far edge here. Okay.
It must be sending a bunch of tabs or something.
Yeah, so the Litton has these weird escape codes for moving to printer column, this and that. I mapped them all to a single tab, so I'm not sure why it's all the way over there.
Yeah. Well, that's something.
Anyway, I think we can let you go to bed, David. I think we've achieved quite a bit, and then we can have a look at trying to get the input side working next week.
I mean,
unless you want to keep going for another hour.
Jesus, no, I need to go to bed. But we got something from the Litton to us via an Arduino. That's like a massive victory in my book, man.
Yeah.
Yeah, and I think, this is great.
Yeah, and it's not like we're missing cabling. Everything's in soft now. Oh, well, maybe some resistors need to be adjusted, but
yeah, most things are in software. We're gonna have to figure out what's up with our output. Why are we getting all these extra device codes that we shouldn't be getting? Is that a signal integrity issue? Is that a sampling issue on the software side? There's about a million ways that thing could go.
with the slightly high 18 volts, we would still be seeing maybe seeing some problems.
Yeah, so I think the next step is to have like a bunch of different Arduino sketches that do different things to test out different functionality. And then, because otherwise we're just going to be sitting there like desoldering and resoldering resistors over and over and over again until we trial and error our way into victory. So if we can use Arduino code or the scope to narrow down exactly what's going on, so it's not so we can figure out why it's not behaving.
Yeah,
that'll get us there, I think.
Yeah, we might want to look at the minus 18 0 volts that is getting control from the Arduino, but we'll leave it at next time.
Yeah, because who knows? Like maybe we're catching spurious pulses or something that, we need to shift the input level on our level shifters around a little bit. I don't know.
Because we don't even know if we're outputting hard enough for the Litton to listen to us.
Yeah. Also, I'm really frustrated that the transistors were backwards. Like, that doesn't make any sense to me. Like the datasheet, like I literally did what the datasheet said.
Yeah, but there was a P before the 2.
Yeah, not on these transistors, I don't think. Or
there's
a P before the 2 on the
datasheet.
datasheet. Oh, okay.
And somebody posted on the Friday Night Litton at some point that having a P2 and something means that they flip emitter and freaking collector.
Yeah. All right.
Like,
well,
why?
it seems to be we're getting there. I don't think we need to desolder much more on those level shifters. They seem to be doing all right.
Yeah.
Yeah. Take it easy, Zadster. I'm headed to bed too. It is late. So thank you guys so much for watching tonight. That's the end of the stream. We'll catch you next week.